So to get started today, we kind of just wanted to go a little bit over the requirements process and kind of show you like this isn't something that, we just kind of made up on our own. This is a process that has been in use for decades, going all the way back to the 60s, even 1960s. Basically, as long as software has been around, this has at least been an idea that people have started to play with. And we kind of just want to give you a little bit of a groundwork of like what this process is, how it's used, why you should care, even if you're working on just like a small scale project on your own. So, what is requirements engineering? So, requirements engineering is the idea of planning and creating a rigorous set of requirements that are discrete and formally defined before you begin developing a project. And when I say before you begin, you can develop more requirements as the project goes. We'll talk a little bit about kind of the different styles of developing requirements throughout the software development process as we go along here. And as I said, this has been used for decades in the software engineering space. I'll be mentioning some things as like newer, more modern. When I say that, they're still within the last like 20 years, not like last week. So kind of just to get started, why do we care about this type of thing? What sort of problems are we having? Why is this not okay? Slideshow. There we go. Okay. So let's just consider a more real world example. This always kind of helps me get in the right mental state for thinking about this stuff. So let's consider we want to build a house. Let's ignore the fact that we have contractors building, the same style of home in the suburbs everywhere right now, and say we have an independent contractor we're going to build our house with. So we go to them and we say we want to build a house. Let's consider that, we just have a vague idea of what we want. So we go to the builder. We say, I want a house that has a kitchen, a living room, say 3 bedrooms, 2 bathrooms. Well, already we can kind of see some problems with that. What's that mean? What does a bedroom mean? Obviously, it's a room that has some type of requirements in the safety space of what a bedroom must look like in standards, but what does a bedroom look like to you? Do you want a master bedroom? Do you want bedrooms on the first floor, on the second floor? So we start to see a problem where if we have no requirements kind of planned out at the beginning, our builder has to do a lot of heavy lifting and we may not like what we get out. So the builder has to guess what you want. Like I said, how big is your kitchen? How big is the living room? Is there a foyer at the beginning? What are the windows like? So they start construction on this vague house you've described to them. Suddenly you go look at it, it's not what you wanted, but all you gave them was a vague idea. So either you end up with a product that you didn't want, or they have to tear it down and begin again. This leads to extra work. This leads to longer development process, more money. All these things are bad. So instead, we approach them with a set of defined requirements and agreed upon goals, a blueprint. We have the exact specifications for room measurements, the house layout, all this other stuff. We are now talking directly to the builder about what we want to design. A big advantage of this right away is if we have to make changes to this blueprint, this design, it's going to be much, much cheaper than trying to make changes after walls have already started going up in our house. We're able to just kind of make changes to the blueprint. Yeah, it takes time and effort to do this, but in the long run, it's going to save us a lot of time and effort to get towards a more concrete definition of what we're trying to build right away. You can still make changes later on. We're building the kitchen. You can decide later on what type of counters and cupboards you want. Maybe the appliances get moved a little bit, but the concrete kitchen was defined and put in place. So I ask if we do this for something like a house, why don't we do this for software projects? And maybe some of you have, maybe some of you have actually gone through kind of full formal requirements processes for some of the software you're building. But it has been my experience that a lot of developers, especially in the more academic and scientific spaces, end up starting out with an idea of a piece of software they want to build, and they start writing a script. They start developing right away. That script then carries over into technical debt as they try and explode or expand this into a more formal project, and they never kind of sit down and define what this project's going to be to them as they do this process. So I've mentioned requirements. What is a requirement? So I'm going to take a quote directly from the IEEE Computing Society. So this is an organization that's been around also since the 60s for the computer science branch of it specifically, and it's dedicated to kind of standards in computing. And this is both in like how you do requirements process, how you do software development. They do formal conferences every year, a number of them about kind of these practices. They define it as a capability or condition that must be met in order for software to solve a real world problem. So in their mind, software is always solving some specific problem, and a requirement is defining a capability or condition. Another definition they provide is a feature or non-functional constraint that the software must provide to fulfill the needs of users and other stakeholders. So the second definition starts to introduce something else to the idea of instead of just solving a problem, it's trying to solve a need. We have different stakeholders and users involved in our software project. If you're a developer just writing a project for yourself, you may think there are no other stakeholders, it's just me. And that is true, but a better way, a more useful way, in my opinion, to look at that is you are filling the role of multiple different stakeholders. You are a user of your software. You are a developer of your software. You're also the client who's essentially paying to build the software because you are paying with your time, energy, and effort, if not also money, to help develop this software. So you are filling the role of multiple different stakeholders and essentially putting on your different hats for each of these roles as you're thinking about the project that you're trying to build and kind of what requirements you want to get out of the project can be really useful. So, as these describe, we need something that is describing the needs of a software system or what needs a software system must provide. And we want these to be written in such a way that we can build them and then test against them. So, as an example, let's think about we want some kind of analysis tool in our code. And now, analysis tool is going to be a little vague because I don't want to tie this to too specific of an answer of a requirement and dig down in the weeds too much. So let's just think of we have some analysis tool we want in our software that's performing some analysis on, I don't know, a file or a simulation run that we've done something. And we want that to run fast because obviously we don't want to sit around and wait too long. So we might write the analysis tool should be fast. The problem is there's a lot of vagueness in this. What does fast mean? Does fast mean on order of minutes, seconds, nanoseconds, days, weeks? Okay. Does that factor in different hardware? Does this factor in different sizes of simulations? What does should mean? Does should mean every time we run it, it should be fast? Does should mean for, 60, 70% of the times we try and run this, it should be fast? There's a lot of problems in this. And if you are working with a different developer, not just yourself, and you take to them the analysis tool should be fast, you're going to have miscommunications immediately because maybe your definition of fast is different from theirs. Maybe they think this means, oh, I just have to make it be fast like 50% of the time, and in your head, you mean 90. So it's much more useful to have a very specific testable requirement like the analysis tool will return results in 2 seconds for 95% of its executions. If you hand this to a developer, they know if they can write tests where if most of their tests are successfully returning a result within the 2 second window, they've met this requirement. But if all of their tests are coming back and they're taking, on order of a couple of minutes, they know that what they've built is not meeting your requirement. So we want to make all of our requirements specific and testable so that when we work with developers, we can get the exact outcome that we're looking for. And one thing I want you to keep in mind here as we go, and I'll reinforce this a bit later, is in the context of this workshop and what we're trying to do here, the developer is an AI. It's an AI agent, and you need to give it a formal, explicit goal to build. Because if you just tell it, write me a fast analysis tool, you're probably not getting the result that you want out of it. Just a quick thing to bring up that does tie back to the housing a little bit is the cost of fixing defects or problems with the system. If you just determine that the system you're trying to build, the software you're trying to build, has an issue and is not going to meet the requirements or the needs of your users in the requirements space or phase, it's a lot easier to fix. It costs a lot less money and time and energy to get this built. But if you're already in testing, it's going to cost more, still not as much as if you're already in like production and have this code out to the community. And so you want to try and find requirements issues early on and kind of code issues early on in the process before you've started doing all your work. So essentially, changes that you have to make early are far less costly and far easier than changes that you have to make later on in the code. Oh, and the other thing is that often these problems that show up later in the code, you might think they're coming from bad code being written, but usually this is either a missing requirement or a misunderstood requirement, or maybe a requirement that was too vague and didn't cover the full use case that a user actually needed, which is causing a change to happen later, maybe in production because the users have gotten their hands on the code and they found it doesn't quite suit their needs. If you had done a better job doing your requirements analysis or your design, you may have caught that issue much early on before you get a bunch of effort trying to do development. So how do we get requirements kind of out of our users? So these always start with an idea. The idea might come from you. It might come from a user. It might come from you see a bunch of people complaining about an existing software and you go, I think I could solve that problem for them by either fixing that feature in that code or writing my own piece of code that'll do that. So as an example, we have an idea such as I want an analysis tool that is fast. Usually, when you see these ideas or these concepts, they're not showing up in the shape of a requirement. They're going to show up as kind of a vague idea or a goal that someone has. And your job, if you're trying to develop requirements, is to take this and convert it down into a specific testable requirement. So how do we go from this? Well, as I pointed out earlier, you want to start cleaning up all of the vague wording in it. So in this case, fast. You need to talk to people, talk to the users who are asking this question. Maybe that's you. Often in scientific codes that you're developing codes for yourself, you are going to be the end user. So you need to ask yourself, what do I mean by fast? What do I mean by an analysis tool? What are the goals? What is this trying to achieve? And so we need to ask a lot of questions. You need to sit down with any stakeholders you can, whether that's you, lab mates, your peers at your university who might be interested in using this software, any of them, and ask as many questions as you can to try and sort out this requirement. And then you're going to write a draft. So, for example, the analysis tool will return results in under 2 seconds. This seems like a reasonable requirement that solves this idea of I want an analysis tool that's fast. It's testable. We can run it. We can just write all our tests. Do they run in under 2 seconds? Great, we're done. However, you go and you talk to more stakeholders to validate this draft that you've built, and you get some of them pointing out that, well, sometimes I run, really big simulations, and running any sort of analysis on this, it's probably not going to be able to do it in under 2 seconds. Most of my tasks are probably going to do it. And so based on this validation, we're able to refine our draft down into a formal requirement that we had earlier of the analysis tool will return results in under 2 minutes or 2 seconds for 95% of its executions. So we have to ask a lot of questions, we have to iterate a lot, and we have to be willing to write a draft and accept that that draft very likely is wrong the first couple of times, and then refine it until we get to an answer we're satisfied with. Now, one other thing that I do want to mention about this is when you get an idea from a user, sometimes it can skew what your perception of the requirements is going to be. So, for example, a user who is using your website might say, I want a chatbot to work with your website. And in your head, you go, okay, great. The goal the user wants is a chatbot. So I need to build a chatbot. and you start writing requirements to build a chatbot. Turns out what the user actually wants is to be able to access important information quickly on your website. And in their head, the only solution for that was to write a chatbot. So they said, I want a chatbot for your website. But it turns out it might just be better if your website has a quick FAQ for frequently asked questions or a really good search engine to search through your website. And so you have to be careful that when you look at these overarching ideas, you aren't letting them skew your perception of what the actual need is. So be careful when looking at an idea and make sure you're actually digging down into the need. So another reason that these are really useful, and I've talked about stakeholders. Uh, there's all kinds of different, I'm going to say, voices involved in a software project. You have stakeholders or clients. These are people who likely are involved in, say, the money side of things. Maybe they are paying for software to be developed to meet one of their needs. They may or may not be the end users of it. They may be managers who have employees who are going to use this code, or they might be the end user. You might be both the client and the end user of your own code, as I said earlier, because you are writing code to suit one of your needs, and you may have to put on these different hats. We also have, potentially managers who are managing a team of software developers. They need to communicate with the clients and inform their developers what the requirements of the clients is. And then you have the developers who are doing the actual code, and then end users who are going to use the code. The point being, the benefit of requirements is that they can help you in communication across all these people. So we have developers who are used to writing software. They understand the software side of things, but they may not understand the real world use case. For example, you have a company that needs software to replace some of their data entry applications. The developers understand the software side, but they don't understand the end user's experience with their current software and what they're trying to replace. So communication between developers and end users is important, but they have different knowledge bases. The developers understand the software, the end users don't. The end users understand the processes they're going through, the developers don't. Having non-vague, formally defined requirements helps you make sure that there is no misunderstanding when you're communicating between these different stakeholders. So it's important to write them in such a way that everyone can understand. And this also leads to trying to keep technical jargon out of your formal requirements when you can, because you want to be able to go to different members or different people involved, whether they're the clients or the managers or developers, and be able to discuss these requirements with them to make sure you have the right idea. So as a brief kind of thing, I want to talk about two methods for performing the requirements process. I'm not necessarily going to advocate for either of them right now, especially because the whole formal process can be a bit heavy for a lot of software projects, but there's some good information we can take from both of these methods and kind of look at like a little bit more of an informal idea of how to get our requirements out. So, as I've said, this has been around a very long time, and a number of these ideas of how you do this have come up. One example is called the waterfall method. And this method, I'm just going to say, does not work. It is a like shoot for the stars, perfect world in the perfect use case. This works great because you'll notice all the arrows on this list go one way. This is a serial set of stages that you perform where you start with eliciting all the requirements for the project right up front. You develop an entire specification for what the project looks like before you move to design. Once you have this full set of requirements, you move to design the software, then you implement the software, then you verify it meets the requirements, and then you deliver the project. Now, obviously, this is not practical in a real world case. Sitting down and trying to get all the requirements up front pretty much never works. You're going to find problems as you do the design that make you have to go back and recheck the requirements. While you're developing the code, you may come up with a new idea or realize, okay, wait, our requirements don't cover this idea. We need to go back and get more requirements from our client. And then we have to go back through the design process and then back to implementation. And like I pointed out previously, any errors late in the process cause this big problem of you have to backtrack and redo like the whole process to solve it. And so nobody uses the waterfall method at this point, to my knowledge, but the kind of stages and process has kind of led into more modern ideas. And I say modern, this method's been around since the early 2000s for the most part, and is at least used to inform a lot of the requirements processes that companies do nowadays, called the Agile method. And instead of building an entire requirement specification for your project right up front, you focus more on a user and what they're trying to achieve. So think of a user and what they're trying to use. So a user is trying to run a simulation, MD simulation code. So the user runs an MD simulation using this input file with this code. That story of how that user is interacting with the software leads into the requirements that you need of, okay, we need to be able to read in that input file type. We need to be able to run a simulation based on whatever data they've given us. This leads to a bunch of requirements. And you take that single story and then you build it. So instead of building an entire specification of the project, we take one story, build it, review it, make sure it works, and then we adapt and we restart the cycle over a matter of a couple of weeks, and we get features out the door really quickly. So neither of these cases are necessarily the right way to work for you. And in most cases, especially if you're working on like a smaller scale project that has a small user base, trying to do the whole formal process isn't necessarily all that useful. But these core concepts of planning first, getting an idea, a formal idea of what goals each piece of software has, building them, implementing them, and using that to refine your ideas as you go is really important. And one of the big takeaways I want you to take from both of these methodologies here is a concept called traceability. So if you remember, when Taylor showed the code that Riprap produced for HeddleMD, he showed those requirements tags on different chunks of the code. Those are telling you this chunk of code was built because of this requirement, and it meets and satisfies the needs of that requirement. This is called traceability. Through the entire development and process, from requirements to delivered product, you want to be able to trace a requirement through the entire process. So this is my requirement. This leads to this decision in design, which leads to this implementation, which leads to this test, which leads to my produced product. If you can't find a requirement that makes sense for a chunk of code, you have to ask yourself two different questions. The first one, is this code necessary? Because if it's not tied to a requirement, that means I've built code that isn't trying to satisfy a need. The second question, if you think that is this code necessary and I failed to find a requirement earlier? In which case, then you need to go back as part of this kind of like, say, for example, the agile process, you adapt to a missing requirement, go back and plan for that new requirement that you found, and then ensure that as you're continuing your development process, you're continuing to be traceable from requirements to final product. So what's this look like in a world with AI agents? So I would argue that these are kind of more critical now than they have been even in the past, say, 10 years. The actual like requirements process has fallen a little bit out of favor just because it feels like, developers can write code really fast. The cost to produce code is less than it used to be. So if I have to rewrite code once or twice, it's not that big of a deal. If I don't have to rewrite it, then doing the requirements process was maybe a waste of time. So people have kind of stopped wanting to do it as much. Maybe they do a couple bits of requirements engineering for their core components and then let the rest go. But let's consider where you are with and without an AI tool right now. So right now, your responsibilities as a developer are you have to plan the code. You have to figure out what is this code going to do? What am I trying to accomplish? You design the code. How am I going to build the system architecture? How am I going to go forward and get this code working? Then you actually do development, you do testing, you maintain the code. All these responsibilities are in your hands. When we move to working with an AI agent, the AI is going to take some of these responsibilities. The first thing it's probably going to take, and a lot of you have probably experienced this already, is it's going to take the development side from you. Maybe you'll still write some code, maybe you'll edit and modify some code, but you're trying to use the AI to do the bulk of the actual code development for you. Then, maybe we get it to do some of the maintenance. We have it like patch and bug test. We do testing. We have it write the tests, run the tests. If it finds bugs, we can have it fix it. Okay, great. But at the end of the day, even we've given it development, we've given it testing, we've given it maintenance, but you still have to plan. You still have to design. The AI can't just elicit and read your mind, as Taylor pointed out, what software you're trying to build. You have to plan and design that software. And similar to the house construction, if I show up to the AI and I say, here's a vague approximation of what I want you to build for me, it's going to give you its best guess. It's going to try. It's highly unlikely it's going to get you the result you're looking for. It's going to give you something that maybe looks close, but then you have to ask it again. But if you can't describe to it exactly what you're looking for, you can't tell and it can't tell if it's actually meeting your needs. Instead, if we approach with a formal definition of our needs through a set of requirements, and again, this doesn't have to cover the whole system, but say you're trying to get these are the core components I need to work specific ways, having a formal description of them, and then descriptions of like what your code's trying to do, the more information and the more specific you can give it, the closer it's going to give you code that's exactly what you're looking for. So kind of the two big takeaways I want you to take here is the concept of requirements, just helping you have a definition for what correctness means in your code and what scope your code is supposed to accomplish. And then traceability, just whenever you're writing code, or in this case, when you're working with an AI tool, you want to be able to look at what it's producing and go, why did you produce this? What did I ask for that made you produce this? And then second, these requirements and this formal definition is going to help make sure that the AI is not misunderstanding your needs when you're asking it to help develop code for you. So are there any questions about this type of stuff before we pass it off to Taylor to start getting some hands-on Riprap stuff going? Not seeing any. Now, this was kind of a machine gun run through a couple of ideas of here, but the core idea really is just you need to think ahead of time to plan out what you're trying to build because the AI doesn't know. You might have a great idea of what you're trying to build, and if you're writing the code yourself, you can follow that. But you have to be able to communicate that clearly to the AI, and the more concisely you can communicate that clearly, the more tokens you're going to save overall as well. Right? If you're ready, you can go ahead and take it away, Taylor.
All right. Very good. Let me see if I can share my screen here. All right. Everybody see that? See my mouse? Okay. Should have a browser up. All right. Good. Um, yes. First of all, I'll just preface this by saying that I've been a little bit under the weather the last couple of days, and I'm a bit worse today. So I'm not sure that my voice is going to hold out for the next 3 hours. So there's a possibility we may be ending today a little bit early, but if I sound hoarse, that's why. Um, so uh, we ended yesterday just getting started with Riprap, just trying to make sure that we could create a fill out a Riprap template on our local machines and see whether the image that it ships with can build and launch. Um, and so I'm not going to spend too much time on that right now, but just to recap, The basic idea behind Riprap is that it is providing scaffolding for starting a project that is going to use agentic LLMs to drive the development, or you can also apply this to existing projects. So if you've got a project that you've already been working on for a few years, what you can do, and if you want to just test this out for a while, feel free to do this on a branch of the project, but you can just apply this template into your existing project, and it'll bring over the various agentic AI skills, the Containerfile definitions, and so on and so forth, so that you can take your existing project and apply Riprap to it. And this is very much a sort of AI analog to our Python CMS cookie cutter that some of you may very well have used, where it'll just scaffold the basic infrastructure for a standard Python package. This is basically the same thing, except for AI-driven development. Um, and one big difference that we'll see later on is this uses a templating framework called Copier. One of the very nice features of Copier is that you can update projects that use Copier. So that's kind of important when we're talking about a field like agentic LLMs, where things are changing so fast. What this means is that if I make fixes to the template, if I add functionality, you'll be able to pull that into your own repository later on by executing a command called copy or update, and we'll talk about that a little bit later. By the way, if you're wondering about the name, uh, so if you've ever been just driving on the highway and you've noticed that there's some body of water where there's a whole bunch of uh, stones that have been laid by the side of the road. Actually, let me just show you. Um, if you've ever seen something like this, just lots of stones by a body of water. That's called riprap. The idea is that it's preventing the shoreline from being eroded by the water. And so what riprap is designed to do to a large extent is to try and protect your code and the structure of that code against the gradual but inevitable onslaught of technical debt. Um, so if we want to get started with riprap, I'll go through the steps that we did earlier real fast here. So there's a line that we could copy right from the riprap README here. And by the way, if you're looking for riprap, maybe Levi, you can post the link in chat, but it's github/molssi/riprap. And so it's this line copy or copy, and then we've got the location of the riprap template. And then the last argument is going to be wherever you want, whatever directory you want this to go in. If this directory doesn't already exist, it'll create a new directory and instantiate the template within that directory. It'll fill out this new directory with all of the stuff from the riprap template. If it's already an existing directory, then it'll just copy in it'll just copy in some of the files that don't already exist yet. And that's how, if you already have a Git repository somewhere in a particular directory, you can execute this command onto that directory. At any rate, what I'm going to do here is I'm just going to copy and paste that command. And what I'm going to call this is MD test, because we're just going to play around with starting a new molecular dynamics code in a somewhat similar way to what we did yesterday. We just tried to sort of vibe code a molecular dynamics code, just enter a very simple, not particularly detailed prompt into web UI, and we just saw what that generated. And what you all reported was you got some very, very different things. We got the full gamut from here is a very simple uh, Litter Jones Python code, 200 lines of Python, to uh, somewhat more sophisticated, but still not particularly extensible solutions that try to incorporate more advanced features like a neighbor list and electrostatics. To also people saying, it just asks me what existing code base do you want to run in? Because who would be foolish enough to create a new molecular dynamics code now? That's too hard. Okay, so copier at this point is going to ask me to fill out some details for this project. And what you fill out here does actually matter, especially in just a moment when it asks for a description. So for the project name, I'm going to just say, let's call it MD test. You can have whatever inventive name you want here. Um, And then this one sentence description. This is actually something that the agentic LLMs are going to be directed to look at. This is going to go in your README. This is also going to go in a file that LLMs are going to look at when they first try and help you work out what your plan is going to be for this project. So I'm going to put in something that is basically taken straight from our little vibe coded attempt to create a molecular dynamics code yesterday. There we said, I would like you to write me a code for performing molecular dynamics simulation. So I'm just going to write basically the same thing. This is going to be a code for performing molecular dynamics simulations of atomic systems using classical force fields. Um, so I'll just hit return on that. Uh, I had mentioned yesterday, so for the base image, depending on what you're doing, you may need something other than just a simple Ubuntu image. If you're doing something with GPUs and CUDA, you probably want to use an NVIDIA base image instead. If you're doing something where you're going to be releasing a project with PyCUDA or with on CUDA then probably you're going to want to use some base image that's already got Conda set up. But for our purposes, we could just go with the simple Ubuntu image. I'm going to use Rust for this project. And then since this is a new project, I'm going to say go ahead and create the skeletal uh, Rust files. So just some initial files that will correspond to uh, a directory structure for your source files, for tests, for maybe just a basic CI workflow file. This is stuff that makes sense if you're starting a new project. If you're applying this template to an existing project, then you might not want to do this because maybe you've already created your initial directory structure. But the default there is yes, Y there. So I'll just hit return. Then I'll enter my name, my email address, and usually BSD3 is a good option. So now what you'll see is I have a new directory. I read copier, the command I just read was copier copy into md test. That has created a directory called md test. So I'm going to go in there. Okay. And now this is important. So if I type git status, this has not been initialized as a Git repository. Now, I know yesterday some people encountered some issues with OpenMM, or sorry, not with open code. Too many opens in the software development world. People had some issues with open code where even though they were trying to execute open code within the container, it refused to run because it said you're not running in a container. All right, there is an issue I've discovered with the hook that I have for open code where um, it assumes that you're in a Git repository, which you may or may not be. So that's a little thing that I need to fix, and I'll try and release an update for the copier template that it includes that fix, so you don't have to be in a Git repository. But right now, I believe the workaround for that is just make sure that you go ahead and type git init inside of this directory. So this is, just to be clear, This is the directory where we've got our container file, our license file, rr.sh. Inside of this file, I want to type git init. It tells me it's initialized a Git repository. If I do Git status now, it's going to tell me you've got a bunch of files, and we want to go ahead and commit all of those. So I would say Git add period would be one way to just commit everything in the repository. If I say Git status, you can say, see, everything now is ready to be committed, and then I can just go ahead and make a commit. I'll say this is the initial uh, template. Okay, so now if I type git status, everything should look normal. We're in a normal Git repository. Everything is should be good there. Now, the next thing to do would be that we could just execute rr.sh for most of you, really for everybody else, that's what I'm going to ask you to do in just a moment. Or if you're on Windows, execute rr dot you can execute rr.bat just from your normal Windows command shell. You don't even really need WSL in that context. You could just you should just be able to run rr.bat from the Windows console. Um, in my case, I've got a slightly unique situation here in that I am currently sharing my screen with a bunch of people. And what I don't want to do is to reveal a bunch of authentication information to everybody. So let me just show you something real fast. If I type uh, rr.sh. Okay, so it's going to build the image, but really it's already built an image like this. And then if I say something uh, like codecs, for example, it's going to ask me to sign in, um, which is normal. But I don't want to sign in front of all of you. So I've got a couple options. I can either stop sharing my screen at this point and do a bunch of stuff while nobody's looking, or what I'm going to do, and again, you all don't need to follow my steps right now. What I'm going to do is I'm just going to exit out of the container. So I'm on my local host machine. And if you actually look at Git status, this has created a file. And that file is .riprap/state. And it's created a few files, but the one that matters is project ID. Um, so what one of the things about how Riprap works is if I look at the project ID, it's just a simple randomly generated UUID. And what is going on there is when you first run rr.sh on a new project with Riprap, it's going to generate an identifier for your project. And then uh, when it creates the images for your project, you'll notice it's creating images that include that UUID in their name. So I've got a bunch of different projects that I'm running with Riprap. So I've got quite a bit going on there. A bunch of different projects with a bunch of different UUIDs. But just in case there's any confusion, what's actually happening under the hood is Riprap gives you a persistent ID for your project, and then it's going to create images for each of those projects, and it's going to create Podman volumes that store your credentials for each of those projects separately. And this is one of the security precautions Riprap takes is the lazy thing that Riprap could do is it could just mount your global uh, credentials for Claude, for Codex, for OpenCode, for anything else. But that's not really the safest thing to do because if, let's say, one of these agents were to maliciously or just because it's confused, mess with your credentials. If you've exposed your global credentials that you're using for everything, that means that it has in some way modified or exfiltrated the credentials you use for everything. Whereas by doing this on a per project level, by giving you credentials that are unique to each project, what is happening here is Riprap is trying to help somewhat isolate the damage that could be done. If something happens to compromise your credentials or to manipulate them in some malicious way, that is only happening to your credentials for that project and not your credentials for everything you might be doing. So that it doesn't make you safe, but it maybe means that certain attacks are going to be a little bit less damaging. Um, so one of the consequences of this is every time you create a new project with riprap and you run .rr.sh again, it's going to create this project ID file if it doesn't exist already. And that's your uniform ID for the project. If you change the name of the project, it's still the same ID. It's still going to be using the same containers and credentials. But if you start a new project with copy or copy, it'll generate a new ID and you'll have to log in again. I don't want to have to log in again right now, so I'm going to cheat. I have already used copy or copy to create something called mdtest underscore authenticate. And I'm just going to cheat and I will copy out of mdtest authenticate. I'm going to copy the project ID that I had already made. I'm going to copy that into my riprap slash state slash project ID location. This is not something that you need to be doing. And then I'm just going to commit that dot riprap state project ID. Um, and I'll just say that I'm adding the project ID. Okay, so now at this point, you can start following along with me. I apologize if that seemed a little esoteric. But hopefully, when you start seeing the container names that Podman is generating for you, it's a little bit less weird. You know now that you can check the UUID for those Podman image names. You can track that back to each individual project, and now hopefully you're not going to be so confused when every new project requires you to log in independently. It's because you're starting your credentialing over every time you start a new project with a new project ID. At any rate, so what I'm going to do now is I'm on my host machine. I'm going to execute rr.sh. And what this should do now is if I type codex, you see, I don't have to log in again because, again, I cheated. I created a project ID earlier. I logged in without, I authenticated with Claude and Codex and everything with that project ID. But you will have to log in to whatever AI you're using here. Um, I'm going to mostly use Claude here. So if I log in with Claude, that should also just run for me without authentication. You'll need to authenticate the first time for this project. If you then exit out of the container and and enter back into the container later on, you shouldn't have to authenticate the next time for this project. You should only have to re-authenticate for new projects. Okay, so now, like I said, what I want to do is I'm in my containers. I'm root at, and then whatever the container hash ID is, I'm in a location called work. If I ls there, you can see I've got all the same files I had before. And what I'm going to do is I'm going to execute Claude, and we're going to start having a conversation with Claude in an attempt to, uh, first of all, plan out this project, and then subsequently to try and implement a little bit of it. And even as fast as AI agents can work, it's going to take a lot longer than even, say, 3 hours to get very far with something as complicated and nuanced as a molecular dynamics project. So we're just going to kind of start this process out, see what Riprap can do to help with the authentication process and or to help with the planning process. And uh, what we'll end up doing here is I'll get the process started, and if at some point Claude spends a long time thinking, then we'll take a step back and I'll show you a little bit more about how Riprap works under the hood while we're waiting. For now, what I'm going to do is I want to execute a skill. Now, like I said, I'm going to explain what's going on under the hood, including how skills work during lulls where we're just waiting for Claude to finish working on something. But it could take 5 or 10 minutes when I execute this command. So I want to go ahead and execute it pretty fast. But we're going to execute a skill. Riprap ships certain agent skills. And basically, what a skill is it is uh, telling an AI how to perform some specific task. Sometimes you might have a prompt that you want to write out that says, okay, I want to start the process of planning the architecture for this code. And then you might have, a long essay that explains how you want to do that. Are we going to follow sort of a waterfall process or an agile process? What are the things that we want to think about there? So instead of having a mini paragraph long prompt, what you could do is you could write a skill that says, okay, whenever I ask you to help me plan the architecture, the overall large scale vision of a project, what I want you to do is do it this way. That's what a skill is. And we can invoke a skill now, which is, again, one that Riprap ships. Riprap skills begin with RR for Riprap, dash, and then I want to use the RR architecture skill. And uh, if you're using Claude, so if you're using Claude, then you to invoke a skill explicitly, you start with that slash, and you can see it all. It's already getting ready to help me autofill from among the skills that Claude has been able to detect. And one of those is the one I want to execute, RR dash architecture. If you're using Codex, just be aware that their skills, you invoke them by using a $sign, and then it would be RR dash architecture. But here, uh, since it's Claude, it's slash RR dash architecture. I could actually tab complete that there. And when you invoke a skill, you can add in additional information in the prompt. So we could tell it additional information. But what this architecture skill is going to do is it's going to take that one sentence prompt that we entered in, the one sentence description where we said this is going to be a code for performing molecular dynamics simulations using classical force fields. Um, this skill is going to look at that, and it is then going to help us walk through some of the high level architectural design decisions that we should really be thinking about when we're getting ready to start on a project of this nature. So in this case, I should be able to just say slash RR architecture, hit return, and let's just see what Claude does for us there. Now you'll notice it says right at the beginning, I'll start by reading the canonical skill implementation, and it's looking for that in a location that has now disappeared, but it was .riprap slash manage slash skills. It's reading some additional files, including it's looking for a file called rqm/architecture.md. This is a file we're going to be trying to create. We're going to try and create a markdown file that is going to provide a reasonably brief description of our overall architectural intentions with this code. And what Claude has just noticed is that right now, Riprap has it has created uh, just a basic placeholder for our architecture file, but it hasn't filled anything out. And that's correct. So far, Claude is behaving in the way that I would want it to. Uh, whoops. So what I want to do now is what this skill is going to do is it's going to tell Claude, you need to go ahead and ask the user some questions to clarify what exactly are they trying to accomplish with this with this molecular dynamics code. Because as you heard from Sam just a few minutes ago, if you want to really say I have worked out the requirements for my code, you have to be very specific. And the one sentence description we wrote earlier is incredibly imprecise. I want to write an MD code. Okay, but there's all sorts of things that could actually mean. One of the first things is, okay, so are you just trying to, do a personal learning project where you're implementing MD uh, in order to try and understand how MD works? That's a totally legitimate reason to do something like this, and I bet that it is going to be the situation for most people that are writing an MD code. Um, when I was first starting as a graduate student, one of the first things I was asked to do was write a Hartree-Fock code. Um, because it just makes sense. If you're going to be working with codes of a particular type, maybe it makes sense to sit down and write a basic code that's going to implement the theory that you're going to be using for the rest of your graduate career. Um, so, maybe we're just trying to do a personal learning project. Truth be told, that's what we're doing, but we're not going to tell it that. Um, because what I want to show you is what happens if we try and plan a code where we expect to have, 10,000 users in the scientific community. We expect people to be running on big, HPC machines or something like that. What would the planning process look like if we're really serious and saying, I want a code that's going to be a competitor to the existing molecular dynamics codes and maybe even implement some other features. So I'm going to say, you know what? Let's do a production code. We're serious about this. And by the way, I should say, you will not necessarily get the exact same questions from Claude or the exact same options from Claude. Or if you're using Codex or something like that, you'll get different options. Um, Hopefully they cover essentially the same material, but they'll do so in different ways with different wording because everything that you're going to get out of an LLM is, at least to some extent, randomized. There's something stochastic about what's going on as these uh, models generate their outputs. And we saw that. We tried yesterday. What happens if we all put in the same prompt and we try to generate an empty code? We get wildly different things. Um, so just as you're answering these questions, try and answer them in the most reasonable way. It's going to say, okay, so let's talk about performance. Are you going to be running this on GPUs? That's a pretty important thing to nail down very early on in a project because the way that you're going to write this code is going to be wildly different if it only runs on a CPU versus if it has to be able to run efficiently on a GPU. And then you want to think, does it run on a single GPU? Should it be able to run on multiple GPUs? We're talking about major architectural decisions where if you make the wrong choice right now, it is going to be painful to change it. If you take a code that was just written to run on CPUs and then you say, well, now, but I've decided, GPUs are kind of cool, you're going to be rewriting a vast swath of your code. So it's very good that we are now answering that question. And by the way, when you put in just the one little prompt in the web UI yesterday, I didn't hear anyone say that the LLM came back and asked you, well, wait a minute, what do you want here? Do you want a CUDA code or do you want something that's just going to run on CPUs? So, okay, what I'm going to do here is, with Heddle, which was kind of the test case for a lot of this, it was running on a GPU via CUDA. I don't want to deal with that right now because a lot of you may not have NVIDIA GPUs. So if you don't have an NVIDIA GPU, you can't run with CUDA. So let's not do that. And parallelization, that's just a whole can of worms right now. So I'm going to do something you would never do in a real molecular dynamics code. I'm going to say, actually, let's do shared memory parallelization via threads. And then I guess we could. So it's giving us the option of saying multiple. So it's in this case, and you may get slightly different results depending on what harness you're using, if it's Claude or Codex or whatnot. Again, the way these questions are asked for you will be different. In my case, it's giving me the option of selecting multiple things. So I could say shared memory and CUDA. So I want to be able to run on CPU threads and have the option of running on the GPU. I'm just going to say let's do shared memory CPU threads. Um, okay, now it's asking a question about extensibility. This is another question that you really, really want to nail down in a project very early on. Uh, because there are very different strategies you could employ for extensibility. If you look at existing molecular dynamics codes, LAMMPS handles extensibility one way. OpenMM handles extensibility a different way. Every code that you might look at, it's uh, usually thought quite a bit about what happens when you add new features to the code. To be clear, in the context of a molecular dynamics code, extensibility would include things like, well, actually, it says it here helpfully. Uh, you know, if you want to add a new type of potential. So, for example, if or a new integrator or a new thermostat. So, for example, let's say that we create an initial implementation that supports velocity relay, but then we want to be able to support we want to be able to support RESPA or something like that. Um, the question here is, all right, so what should be the process for adding in those new features? How much work needs to go into architecting this code so that if somebody says, maybe you've got a research team that is interested in developing some cool new thermostat. Some teams decided we've got an idea to build a better thermostat than anyone's ever seen before. If they want to implement that in this new code, what is that going to involve? And so there's a few options here. Notice this ranges from things like we could just say, you know what, we're just going to say extensibility isn't something we care about. We already know exactly which thermostats and exactly which integrators we want to support. And we don't really anticipate that we're ever going to add any more. So if extensibility is unpleasant, then, well, that's okay. That's one option. And in certain contexts, it might be a perfectly legitimate option. Um, at the other extreme, uh, Claude is giving us this choice of saying, well, I want a dynamic plugin system. Okay, so this would be saying, I want to actually have a system where somebody can develop code totally independently from this code that we're working on right now. Somebody should be able to create a new repository that doesn't explicitly link against this molecular dynamics code we're creating or vice versa. And we want this code to be able to discover those plugins that have been independently compiled, independently developed at runtime, so that you essentially have at runtime, you've got this ability to just modularly swap in or swap out different plugins. Okay, that's a very extreme version. These are basically three and four are kind of two opposite sides of a spectrum. Uh, Option number one is somewhat more in the middle. This, by the way, is what Heddle does. So here, what we're saying is um, we're going to have we're going to have REST traits. In other words, a sort of standardized interface. This is like a C++ abstract-based class or something like that if you use C++. But we want to have some standardized interface that all the potentials use, that all the thermostats use and whatnot. And then you'll just say every new potential or thermostat is going to implement the potential trait or the thermostat trait. This is sort of midway between the two extremes that I just mentioned. So sure, let's go with that. And by the way, if these sorts of concepts don't make sense to you, you haven't really thought about extensibility all that much. Actually, let me go back. I could press the left button and go back to a previous question. Um, Something you could do is you could say uh, this works a little bit differently for different AI agent harnesses, but at least in Claude, what you could do is there's an option here. Option number 5 is, write your own option. If you've got a great idea for how extensibility should work, you could write it here. Or, something we could write is, I don't really understand extensibility. Uh, can you please uh, describe the implications of these different choices before we continue? Okay, so actually, I'm going to do that. It's totally fine. And sorry, I'm just noticing that on the screen I seem to be frozen. Can you all still hear me, or have I just dropped the connection?
We can still hear you, Taylor. You're good.
Okay, good. Um, okay, so I can say I'll tell you what. Let me stop my video. Oh, I can't. Uh-oh. The Zoom interface is frozen on me. That's why I'm frozen here.
Yeah, we can still
Um,
see what you're doing on your screen
okay.
too. So
Okay. So what this means is I can't stop sharing on my own. But we'll try and make that not be necessary. Okay. So so I'm just going to say, can you please, it's totally fine. If you don't know what these things mean, then you know what you need to, if you're developing a project, you need to have some idea of these higher level design choices because this is your responsibility now. There is a certain
we appear to have lost Taylor briefly. We'll get him back real quick. In the meantime, if there's any questions people have, feel free to ask them now in the chat as we are going through and we're getting Taylor back in. There's been a couple questions that were asked in the Q&A, and I want to briefly address those. Um, the first one was, are the questions that were being asked to Taylor sort of generic, or how are these being managed by Riprap? And is that the questions were being entirely generated by Riprap's defining the skill for that AI agent to actually understand and interpret, but then it's coming up, the agent itself is coming up with the questions to ask you based off the description that you put into your project. Um, so all the questions you were seeing were entirely based off what Taylor had provided at the beginning, and then sort of the model he was using effectively, and whichever agent, and that was just how it worked through that. Um, the the other question that was asked was, for projects that already exist, which is instead of starting from scratch, if I have some project I want to just start using the AI agent with, can I still use Riprap? And the answer to that is yes, you can. You might have to do some tweaking of the Git side of things once you initialize your project. But there's nothing stopping you from taking the existing code base and then once you're in there, working with the agents and with Riprap to actually still build up the architecture, build up the requirements, which we'll be doing a bit more of once Taylor comes back. And also and then saying, we're working with this existing code. Now, because I will caution that because if you are starting with an existing code, there will be a history associated with that code from all the other developers who have worked with that in the past. And so how you build up the architecture and the way you phrase the questions and the requirements will be different than if you're starting from scratch. And I would caution that you are careful in that decision process and also making sure that your agent understands that this is an existing code base. And there may be some things that you definitely do not want it to touch, and that will be one of the requirements you sort of specify. And Taylor or Sam will help cover that as we get into the requirements beyond just the architecture here in a minute. With that said, Taylor, you are back. I see. Can things good on your end?
Yes. I think so. Let me try and share my screen, and we'll hope that that doesn't happen again. About where was I when I dropped?
You had not submitted your question yet, so you dropped basically
Okay.
right in the middle of that. So carry on.
Okay. So I think what the last thing I'd been saying was, it may be that you don't really know much about extensibility. Had I said anything about this before I dropped, or uh,
Yes, yes,
so
you had. You were talking about if you know nothing, how do we get more information out of
right,
these agents?
right. Okay. So you know what? Instead of just guessing and reaping whatever outcome you get, Uh, what you can do is you can just tell the LLM, you know what, I don't understand this. Can you please describe to me the long-term implications of, in fact, let me just say, can you please describe the long-term implication of these different choices before we continue? Because, if you're starting a new project, I think Levi was just talking about how, if you're working with an existing project, you should follow the existing architecture, which is correct. But if you're starting a new project, you really need to be making the correct large scale design decisions. You need to be making the sorts of decisions that traditionally a more senior developer would be making. So if you don't know, you know what? An LLM is a great opportunity to try and explain it to you. So I'm going to, what's going to happen is I'm going to submit this custom answer that I have selected. And then so what happens is with Claude, at least, these questions are submitted as in a batch. So I've got four different questions it's asking at the same time. I'll go ahead and fill out the next question, and then Claude's going to respond after I finish filling out this question, and it should try and explain to me what extensibility is. So what I'm going to do here is let's see how broad is the force field scope. So what sort of potentials do I want to be able to support? So short range potentials like Lennard-Jones, sure sounds like I want to have that. Bonded terms. So if you want to have anything with bonds, okay, you're going to need that. Long range electrostatics, okay, but most steady molecular dynamics code will have that. This is where things get a little more complicated. Do you want to support something like machine learning potentials or other more sophisticated potential terms? You may or may not want that, depending on what your interests are. So this is one of those places where, again, it's important to know right off the bat. All right, is this going to be a code that's really going to focus on, some exotic potential form, or am I going to do something somewhat more standard? You should really know that, and you should let the LLM know that before you go just writing code. And of course, we've got the option of saying, something else. If we've developed some new functional form, and maybe we could say, maybe we've added a paper that we published into this directory, and we might say, read my paper.pdf. Uh, it needs to support the potential for describe described therein. Therein, is that the spelling? I think that's the spelling. Okay, of course, we don't actually have a mypaper.pdf, but you might say something like that. Now I'm going to click submit. And at this point, uh, what should happen, I hope, is that Claude will explain what extensibility means. Good question, and it matters a lot here because you said production community code. Okay, so it's actually going to uh, it's going to go through each of those options that it gave us, and it's going to tell us a little bit more about what the different implications are, and we could continue to have additional, we could have a long conversation with it at this point. Um, But at any rate, so entry traits, that's option two. It's listed there, and it actually recommends, try option two now. That's actually what I would do. So now it's giving me additional questions. It's just returning back. I've explained a little bit of this to you. Now, which of these do you want? And so entry traits was what I was going to do anyway. It is raising the question of, do you want to have a public API right now? This is fine. Option one, the recommended one, we can go with that. Um, and then it's going to ask additional questions. So this is actually kind of a follow-up from do you want traits or not? And I'm going to go with the same design. Since we asked questions about this and we indicated we're especially interested in extensibility, it's kind of breaking that down into a few different questions now. Okay, now here's a new question. It only asks you so many questions at first, but there's a lot of things you want to work out if you're creating a molecular dynamics code. And one of those questions is, okay, so how do you run it? What option would be, and they don't give us this option, but maybe I want some nice fancy GUI that users can use. That's not common for molecular dynamics codes and that production, scientific runs use. But maybe that's your cool feature is you've got a really clean GUI so that it's very easy for someone to see the structures that they're the initial input structure that they're using and whatnot. Um, the typical choice for most codes is going to be, well, you have some sort of input file. So this is what they're talking about. It's a CLI, command line interface. So you type on the command line, in the case of Heddle, you type HeddleMD run, and then the next argument is going to be the input file you want it to use, and that's a TOBL file that is going to include all of the configuration information for the run you want to do. So that's a pretty standard choice. You could also alternatively say, well, I want people to let's say use Python binding, so I want people to write a Python script. That's how some scientific codes do things. And some of them will do both one and three. So for example, Sci4 basically does one and three. That's a gas phase quantum chemistry code, but you might have multiple of these. In our case, let's just go with one. But again, this is a place where if you wanted to continue to have a conversation with the LLM, you could do so and try and make sure that you're making an informed decision on these points. All right, now here's an important question. How do we handle testing? I had mentioned to you when I was talking about HeddleMD, one of the things that I always found was wherever there were cracks in the testing is where regressions inevitably cropped in. Human beings are not particularly good about modifying code without breaking something, and LLMs are not uniquely better. At least not in my experience. If they don't understand something, if the reason why a block of code exists isn't obvious, they will happily break that block of code and move on. If you're trying to improve performance, they may very well break some of the physics of your system in pursuit of better performance, or vice versa. They might fix a physics bug and not care that they've just made the whole calculation take 10 times longer. So this is really important, and there's a few different options here. Um, we could have, so this first option that it's giving us is something somewhat akin to what HeddleMD does. You have some sort of standardized set of tests that are going to enforce, look at that, analytical versus numerical force slash virial consistency. That's exactly something that HeddleMD does. So that we would want physics level end-to-end tests. In other words, I run a simulation for 1,000 iterations or whatever, and I confirm that it doesn't explode, that the temperature doesn't, shoot up to near infinity or something like that. That seems like a good idea. Reference data regression. That might be something that you want as well. So that would be the idea that I've run some simulations and I've checked to see what results do I get out of those simulations. And then I say, okay, uh, I'm going to expect that if I run with the exact same simulation with the exact same initial seed and whatnot, I should get pretty much the same result. Now, there's some nuances there that it mentions, which is, okay, you have to compare within a tolerance because, of course, uh, if you run this multiple times, most MD codes are not bitwise deterministic, at least not all the time they aren't. Uh, and so you would have to accept some tolerance. Uh, my new trajectory compares with my old trajectory within some tolerance. You'd have to figure that out. That's a good thing to have, although I will just say, if we don't initially know whether our code is working right or not, we kind of have to get to that point before we create our golden tests. Um, so for our purposes right here, I'll just go with 1 and 2. That's fine. I mean, we're not going to implement most of this anyway, but you would want to consider uh, any and all of these and maybe more because you could never really have too much testing. But let's just go with that. So we'll submit this, and then what will happen is Claude will either create a new architecture.md file for us that reflects all of these choices, or it may have additional questions to ask us, follow-ups from the questions that it previously asked, or additional things that we should consider. 2 more batches at most. Okay, so we're going to do this at least 2 more times. And you might think, well, this is a lot of questions, and it is, but really, I want you to appreciate these are the things that you should be thinking about before you ever start writing any code. You should have answers to these questions. And if you don't have answers to these questions and you change your mind about something, or you realize that you didn't have anything resembling a plan for it, and you try to bolt on, a new testing regime later on, late in the development of your code, you will have paid a price for that failure to plan ahead. We don't have to have all the details planned. We don't have to think about every possible nuance. That's something that's going to happen later as we plan individual requirements and as we implement the code. But we should have a high level vision. We should have a sense of what the architecture is going to be. And this is exactly the sort of thing that if you're just, a graduate student just trying to find your way, this is exactly the sort of stuff that you haven't been exposed to. And so what I'd encourage you to do is use Riprap. Make sure that it has helped you ensure that you have thought through these questions. You know what? Imagine a scenario where we don't use Riprap at all. We don't use agentic LLMs at all. We just code everything as a human being manually, but we went through this initial architectural design phase to force ourselves to think through what is our vision. I promise you, you will write a better code having gone through this process than you would have if you just sat down and said, yeah, I'm going to write an empty code. It's probably easy. Um, okay, so it's saying what ensembles and constraint machinery are in scope. So in other words, do we want to be able to run uh, do we want to be able to run with thermostats? Do we want to be able to run with barostats? Do we want constraints? So in the case of Heddle, it's all of the above, all of the above. So those are all things that you want to think about. You're going to have a little bit of a different design if you want to support MPT versus if NVE is fine forever. Uh, Okay, a question about major dependencies. Okay, so if you're at all familiar with how molecular dynamics code works, if you're doing a particle mesh evolved implementation in order to evaluate electrostatics, that involves doing fast Fourier transforms. I do not recommend that you implement your own fast Fourier transforms. Um, many people have gotten PhDs from figuring out how to best implement fast Fourier transforms. You do not want to get bogged down in those details. So, uh, you know, we one of these options is hand roll the FFT. That means write it yourself. Don't do that. I don't recommend that option. Um, but then another option is so that's one extreme that I would tell you to stay away from. But then the other extreme is just, use whatever you want anytime you want. I would usually suggest something that's a little bit more midway in between. And the reason comes down to this point that I have made earlier that supply chain risks are becoming a serious challenge. And one of the ways that you can reduce the likelihood that you get hit by a supply chain attack is to limit the size of your supply chain. So my suggestion would be, obviously, you're going to want to use some sort of FFT library for the particle mesh evolved. Obviously, you're going to want to use something for some existing framework for implementing parallelization. That's what Rayon is, by the way. That would be for threading and Rust. So those are pretty obvious. Um, if we've got vector math involving 3 by 3, do we really need to bring in a linear algebra library if that's all we're doing? Maybe not. If it turns out later on that we're doing more linear algebra than we expected, then maybe we'll bring in a new linear algebra library. That seems fairly reasonable to me. If we want to bring in a new dependency later on, that's not the end of the world, but we definitely at least want these. So I would say that option one is a good happy medium right now. Um, but maybe you have no idea what is Rayon. Okay, right? We could once again say, I don't really understand what you're asking me. Please explain this before we continue. So we could repeat the process again. Again, I'm going to encourage you, make sure you understand what you're doing, or you can click option 5 there, chat about this. Again, it works a little bit differently in Codex versus open code. By the way, I probably should have mentioned this earlier. In Codex, Codex is a little bit weird about how it works with this skill because in Codex it's an annoying thing about Codex. But Codex can only ask you multiple choice questions like this if you are in what's called planning mode. But in planning mode, it also can't write files. I want this to write an architecture.md file. So that means that Codex isn't super well aligned with the workflow that I'm advocating for. One thing you can do is if you're using Codex, switch to planning mode when you first invoke our $ RR dash architecture. It should ask you multiple choice questions then, so it should be a little easier to go through this process. And then once you get to the end, you can let it switch to normal mode where hopefully it's going to write out the file. So you just maybe switch to plan mode before you do this. I should have mentioned that earlier. But anyway, so I'm going to say lead. What output and restart capability does it commit to? And so, you could say, I want to have checkpoint files and whatnot, or I want to, presumably you want to be able to write trajectories at a bare minimum. Maybe you want to support checkpoints, maybe not. Let's just go with trajectories for now. Um, and then it's asking, okay, so here's some pretty big things that we just want to make sure we've confirmed. Uh, do you want GPU acceleration? Now, it kind of asked this already, but it's double checking. It's like, okay, if you want GPU acceleration, we really, really need to make sure. Are you telling me you do not care about GPU acceleration? And for this purpose, I'll say, sure, I don't care about GPU acceleration, but for a real MD code, usually you would. Um, and are you saying you really, really don't care about MPI? Well, that's what we said it before, so we'll stick to our guns there. Um, do you care about something like QMMM? No, I do. I'm going to say I don't for the purpose of this. Do you care about machine learning potentials? Well, I'm going to say for now, if at any point you think I might want my code to support machine learning potentials, then you say, yeah, at some point maybe I do want to support machine learning potentials. But we've got an hour to spend on this, so I'm definitely just going to say that's a non-goal. No, don't worry about it. Stop asking me about machine learning potentials. Um, okay. And it promised us two more batches at most, which means I'm expecting to be asked another set of questions. And again, maybe it seems like this is a lot to begin a project, but truly, if you're going to be spending, um, you know, years of your life on a project, or even a few months, or even a few days or weeks, it's worth spending a few hours at the outset to consciously think about what am I actually trying to accomplish here? What what should be the end state of this project? Oh, it's okay. So it's decided that's the answer to everything. It promised me two more batches and it just gave me one, but that's okay. So what it's going to do now is it's saying I'm writing the document, and what it's going to do is it will uh for some reason. Oh, here we go. It's let me just while it's working on that. Okay, so here I just opened up a new tab and I'm not in the container, which is fine. But I just want to show you something. So there's a file rqm/architecture.md. This was created when we initially made the Riprap template. And this is just a placeholder. You can see it says it's a placeholder. This is the file that Claude is supposed to be updating. It'll take everything we've just talked about, all the decisions we've made over the course of this question and answer session, and it's going to it's should oh well, that's interesting. I never said you're allowed to write. It never asked me if it could write. So just something that's worth keeping in mind. Usually, LLMs are supposed to ask permission before they do things. You notice I've got something called manual mode on. It says that in the bottom left there. It's not supposed to overwrite files unless I tell it it can overwrite files. It just overwrote a file without checking if it was okay for me to overwrite a file. That's not usually what's supposed to happen. If I look at this file again, notice it has just overwritten something without asking my permission. This is one of the many reasons why you want to be running your AI agents inside of a container so that it is not modifying your system files without your permission. Even if it's supposed to ask, sometimes, and I've experienced this many times, sometimes it doesn't ask. Okay, so uh, now we have this file. You can see it has it replaced what it's telling me is it's replaced these lines that are in red with this. So let's just take a look at what it's written here. Okay, empty test, uh, molecular dynamics simulation intended for scientists outside the originating group. In other words, it's we expect this to be designed competently and not just sort of an ad hoc thing to play around with. Um, and it's saying, okay, we're going to run on a single machine in threads across its cores. Um, it's included some information about, what we said this should be able to do. It needs to be able to support thermostats and barostats, and it needs to support constraints and so on and so forth. Here's the input file. It's supposed to support some sort of input file format. Um, so it's basically just written out the things that we just discussed. And this would be a good time if you're doing this for real, read through in detail, confirm that everything looks good. Uh, and let's say that you don't like something. Uh, then what you would do is technically you could edit the file directly. But I wouldn't recommend that for the simple reason that um, if we're going to continue working within this context window, if we silently edit a file, Claude isn't going to know that. So if there's something about the architecture it wrote that we don't like, we should just explicitly tell Claude and tell Claude to make the change to the architecture file. And the way that we would do that is well, let's think about a change we might want it to make. So something it's mentioned here. It made a judgment call. Notice this is sort of its debrief with us. It said, I made a judgment call instead of asking. Well, that's probably a mistake. It probably should have asked us about some of these things. Uh, it it decided we're going to use double precision floats everywhere. Well, maybe that's not what I want. Maybe I actually want a compile time option to switch between single precision floats and double precision floats. That's kind of an important enough architectural decision. It might be worth uh, addressing now. So the way you would do that, let's say that we want to change something, we could just invoke RR architecture again, but this time I'm going to provide it with, I'm going to tell it specifically what I want to change. The first time you execute RR architecture, when it's just a placeholder file, it'll go through the full battery of questions. But later on, this is kind of what Sam was getting at when he says, you can try and do waterfall where you've got this single linear approach where you start with you start with your design or once you've got your design, then you go on to the next step in the waterfall. You never go back to consider your architectural decisions. Uh, that's not realistic, especially to scientific programming. So there's going to be times when, even though it's not ideal, you may have to go back and reconsider some of your big design decisions. And in this case, of course, it's free for us because we haven't implemented anything. So this is the time to make any updates. What I'm going to say is, okay, RR architecture. Uh, I would like a compile time choice between F32 and F64. So maybe that's something that really matters to me. And what should happen now is it shouldn't have to ask me 30 questions. It should just, in fact, it may not have to ask me any questions to clarify that, because that's a pretty obvious thing to change. What it should do is go back and edit that file so that any places where it said use F64, it's going to say, there will be a compile time option to choose whether you're running single precision or double precision. Okay, I know I've gone for a while here. Any questions so far?
Yeah, there's been a couple questions that I think I've been able to answer mostly in the Q&A, and you can look through those, the answered if there's something there that I either got wrong or stands out to you. But yeah, so any other questions, people feel free to put in the Q&A, put in the chat. I'd also like to encourage people, if what they've been able to generate so far through their own LLMs and agents using Riprap and sort of what you've architectured out, and if you found things that you hadn't thought of that it did, or also are there weird decisions that the LLM made that you weren't expecting and you think it might be wrong? Just even something like that posted in the chat here, just to give people some flavor of what other people are experiencing. So let's see if people come up with stuff to put in the chat over the next couple minutes while we wait for, it looks like, Taylor's decisions to go through as he's rerun
Yeah,
the
so
architecture.
while people are writing that, I'll just as you can see, I said I want you to give me a compile time choice between single precision and double precision. And it's pointing out, so there is a potential issue when you're accumulating pair energies, that just using single precision might not be sufficient there. And so it points out that there are other codes where molecular dynamics codes like Growbacks, where uh, F32 mode isn't exactly strictly single precision. It's technically mixed precision. They do most everything they can in single precision, and then some things are done in double precision. And so it's asking me, so what do you want? Do you really genuinely want everything to be single precision? The answer is probably not. So this is actually Claude stepping in here and pointing out that at least as originally written, the idea that I gave it probably isn't quite right, or it needs at the very least to be elaborated on a little bit. So it's giving us a choice, and I think what we want is mixed precision. That sounds good. Uh, and how are we going to want to express the choice? This is actually, I think this is getting too into the weeds for a high-level architecture decision, but I'll say that's fine. Um, and then how should the test suites handle the two precisions? Uh, okay, so that's an interesting question. When we run the tests, do we run the test twice? What's in single precision and what's in double precision? The answer is probably we should. So fine. Okay, so that's now working. Anything in the chat noteworthy? You're muted, Levi.
Yes, I was. So the chat's been kind of quiet. Still encourage people to use it to, post what some of the things they have. But there is a question that's in the Q&A that's come up a couple times, and I'm going to loosely and paraphrase some of this. And if I get this wrong for any of the people who actually asked this question, please correct me in the chat. First off, is that it looks like Riprap is mostly configured to read to basically start from a blank, so a non already established code base. And I believe one of the crux of the question is, can we apply Riprap to a existing code base? Um, to which my general answer for that is yes, you might have to, like, you can still pull down, the other code into your working folder, which will get mounted to the container. You just might have to do a bit of things with the Git, a little tweaking with the Git to establish what files need to actually be correctly added. And then the follow-up question, at least in the QA, is Riprap going to support languages other than Rust and Python? To which I would, if I remember correctly, is that Rust and Python are just kind of the defaults here, but there's nothing precluding your agent from being able to work with another language. And that the language choice just sort of helps steer the initialization, and you can specify once it's already established, um, we're actually going to be using this language, or maybe we're making a wrapper around, say, a Fortran 90 code or something, and that it's mostly a F90 code, and we're just also needing a Python wrapper or something.
Yeah, there's nothing fundamental about most of what Riprap is doing that ties it to either Python or Rust. And in principle, yes, I mean, I've tried to design it so that it can support additional language. I've tried to make it extensible on that front. But so basically the places where Riprap is not agnostic to language would be things like there's a number of in the skills, it'll give examples of, here's if you write a code, here's how you should, uh, write out the requirements traceability. And that looks a little bit different for Rust versus Python, for example. So the examples that the skills are that say Claude would read are going to be in Rust if you configured with Rust, or Python if you configured with Python. If it's a Fortran code, for example, or a C++ code, um, Claude usually should be able to figure it out still. So even if you use the template as is and you just picked um, and you picked Rust, but it's actually a C++ code, it should still pretty much work. It just might make slightly more mistakes about certain things, especially how it maps the requirements into your your source code. But if there's demand for particular languages, feel free to communicate that. Feel free to put that in the chat. Um, so it finished, and once again, it modified architecture.md without asking me, which always is something I appreciate. But you can see it's just written a bunch of code here. Previously it had written F64 throughout, and it's updated that to precision. There's a compile type float32/float36 option, and then it's given some details about this, which again, frankly, gets a little bit more detailed than what I would typically expect in a high-level architecture.md file. But that's kind of a thing that happens if you ask it to make a modification. It won't necessarily right size the modification. It's sort of like it feels like it has to prove it's doing work. But at any rate, so now would be a time when you really want to sit down, read through that architecture.md file, make any additional changes. We can keep executing RR architecture as many times as we want until we until we're happy. We've made all the changes we want. By the way, as for that question, can we incorporate this in an existing package? What I would suggest is if you are trying to use this with an existing package, start off by typing RR architecture, and I would say something like, um, please examine this code base. Um, please help me create an architecture. I didn't spell that right. Architecture.md file. I would probably. So I'm very pedantic, by the way, in case it's not obvious when I'm writing out prompts to AIs because you want it to be you want clarity there. So
Taylor,
please help me create. Yes.
if a couple things just to interrupt you there. You are not sharing your screen, so if you wanted to show what you're sharing, that we weren't. The second thing is, it was pointed out to me in the Q&A by somebody who posted anonymously, and I thank you very greatly for this. I made a mistake when I configured the room, and I had turned off chat. That should be on
Oh,
now. So
okay.
you should be able to chat everybody in the normal chat room. I am terribly sorry about that. So yes, I'm glad the Q&A has been working at least. But yes, chat should be enabled. Yes. Okay. All right, and there. And Taylor's back to sharing the screen. Yeah. So yeah, my apologies. And it also looks like I might have also in reconfiguring this clicked something on my end. So we are good. The screen is back up and chat is enabled. So carry on.
Okay. So if people have been having issues or have questions, feel free to go ahead and we'll try and pause in a minute or two after you've had a chance to write that out. So at any rate, I know there was that question. What would I do if I'm implementing this in an existing package? And what I would tend to start with after I copy into the top level directory of that existing repository, the first thing I would do is run RR architecture, and I'd say something like, please examine this code base, help me create an RQM/architecture file and I would probably say something like reflects the state of sorry, I've got a Zoom window in the way. The state of this code, and then if you've got some ambitions that aren't already reflected in this code, uh, but with the change that the code should eventually support such and such a feature, or something like that. If there's some major architectural, design decision that you're wanting or, should support uh design decision, whatever. Okay, so I'd probably write something like that, and it should be that just by looking through the files in your directory, it should be able to pretty well populate this. In fact, it probably wouldn't ask you even that many questions because it can infer those questions from your existing code base. Also, I think yesterday a question was raised about, how uh, what is the sort of or should there be concerns around whether code that I share with an LLM is going to be trained on? And the answer is yes, you should be concerned about that. Um, so with most companies that are running an LLM, um, they're going to train on every conversation you have with them. I think Anthropic gives you a setting where you can say, please don't train on my conversations, and there may with some of the other providers there may be something like that. Although for the most part, the assumption should be they're training on everything you do, which means if you're developing code, and even if they say no, 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 we promise we're not, I still wouldn't believe them. I'm not going to trust that if I tell Anthropic, don't trade on my conversations. I'm not going to trust that next week they're not going to change their terms of service and retroactively read every conversation that I've had and trade on it. I'm just not going to trust one of these companies with that. So I think you should just operate under the assumption that whatever information you reveal to the LLM is going to be part of that LLM's trained data set and is therefore going to potentially be accessible to anybody else. If that's a problem, then what you should be doing is running with a local LLM that's running on, a local cluster. And even then, be careful about what sort of internet access it has. Also, this is one of the places where I would suggest that having everything running in this rootless containerized context is very, very important. Because what's happening here is uh, Claude, in this context that I'm running it in now, it has access to everything in the container, which is to say it can access, but basically the only thing of consequence that it can access is what's in /work. So the directory where I launched rr.sh, it can see anything there. You should assume it's going to see anything there and read any of those files. But if I've got, if I've got my personal finances written in an Excel spreadsheet somewhere else on my hard drive, it isn't going to be able to see that because that's not in /work. That's not been mounted into the container. So one of the things that this gives you is it bounds the privacy loss. Otherwise, if you're running an agentic LLM, my suggestion would be if you're running it outside of a container, you should just assume that Anthropic or OpenAI or whoever has everything that's ever been on your computer. It might not. It's not supposed to read things by without asking your permission. But look, Claude just wrote a bunch of stuff without asking my permission. It happens all the time that these LLMs read things without asking, even if you said, don't do that. So this is one of the many reasons why I would suggest you have to be running in a containerized environment whenever you're working with an LLM, because otherwise you're exposing everything to exfiltration. Um, okay, anything from chat that I should stop for here?
Um, there's one question about using a local LLM. So I'm assuming, based off the context and questions that this individual has asked before, that this is not necessarily something with its own standalone interface like Claude or OpenCode or or Codex. And so I believe the answer to this would simply be whatever you're doing to access it through your current terminal, you'd either have to build it into the image and then communicate to wherever that LLM's network is, or if it is
Yeah.
using like open code, then once you're in the container, you just have to connect it to your local LLM.
Yeah, let me just return to that in just a moment. But first, I should start Claude working on something while we discuss that question. So we've generated our architecture file. Let's pretend that we've actually done our due diligence and read through architecture.md in detail, and we've made any edits to our satisfaction, and we're ready to move on with the next step. Now, a big question is, what is the next step? you can see that actually I haven't typed anything in here, but Claude is giving me a suggestion. It tries to guess what your next prompt might be so that you can just press tab and tab complete the thing and hit enter so that, it's the ultimate in vibe coding. Don't even think about what you're prompting, just hit tab and go. Um, but so what it's saying is maybe we should plan the short range pair core. So in other words, that would be something like Leonard Jones interactions. Well, I'm not so sure that that's what I want to start with. That's just what Claude has guessed right here. Instead, so this is actually one of the hardest parts of starting a new project is figuring out, well, what do I start with? Before you've even got some core functionality that runs, it's a little bit hard to say, where should I start my requirements planning next? What should I start implementing? So what I would do at this point, and so a lot of what we're doing here over the course of this little experience is we're sitting down, we are working through trying to figure, or I'm trying to showcase to you what the workflow that I use with Riprap is. Uh, and you can try and figure out if that works for you. You can make adjustments as you wish. But at any rate, the next thing that I would probably do here, because it's pretty overwhelming. If you think about all the stuff we wrote in architecture.md, we wrote a lot of stuff. And so one thing I might just do is I might say when considering uh, architecture.md, what would be the best place to start? Can you provide a a rough uh, plan? Let's see. I don't want to say plan because that's overloaded. A rough. Can you let's say can you divide the key work into reasonably ordered phases? Okay, so let's just see whether Claude can suggest to me something reasonable as far as what order should I get started in? What should be step one, two, three, and four? It may or may not have something useful to offer there. While it's working on that, I want to go back to the question earlier. What happens if I'm working with a local LLM, or let's just generalize that to what happens if I want to do something other than the trifecta of Claude Code, Codex, or Open Code. Um, so we've got our top level container file. You can add to this container file to have it install some additional agent uh, if needed. So you can set this so that if there's some additional tool that you want to be running in this container, you can adjust that. Also, let's say that you need to open up a port or something in that container so that it can access your local model. If you look inside of riprap slash, let's see, it would be user Podman run options. Okay, here, so when you run rr.sh, it's automatically going to launch with a certain set of options that include mounting your top level repository directory into /work. So it includes and things like -it that Sam showed you earlier. So you run in an interactive terminal session. This file allows you to say, I want to supply additional command line options to Podman when it launches this image. And that's important if, for example, you need to open a port or let's say that you want to develop a CUDA code that needs to have access to your GPU. Well, then what you would need to supply is a special option that is dash dash device equals NVIDIA, etc. You would need to enable that option. And now whatever your container launches, um, you should be able to access your NVIDIA GPU if you have one from inside of the container. So you can edit your container file to add additional dependencies, including additional agent harnesses. You can edit this file in order to adjust your launch options to accommodate any special needs you might have there. Okay, so Claude Code has finished thinking. Uh, all right, so what it is suggesting is it is dividing the work up, it looks like, into 12 phases. Here's how it's suggesting we do. First of all, apply a foundation. We're basically just going to set up our internal representation of the atoms of our simulation cell. Uh, basically, this is just implementing some basic data structures, which seems not unreasonable to me as a starting point. Then it says what we're going to do is implement our first potential. We're going to implement we're going to implement Leonard Jones, and more generally the trait, the interface that we're going to use throughout the rest of the project for potentials. We'll evaluate those Leonard Jones forces in a very sort of simple way. We're not going to worry about a neighbor list just yet. And then finally, we'll start to get in phase three, we'll implement an integrator. And this is presumably the first time we could, yeah, it says first real science. So phase three is when we can actually run a simulation. And then we start thinking about neighbor lists and, adding in additional things. We would implement constraints pretty late in the development. Um, so we could probably think through this and decide, maybe there's some adjustments we want to make. But what I'm going to do right now is, especially since we want to actually start making progress on this, I'm just going to say, let's see, I'll say, please write this, uh, please write this analysis to a top level uh, plan.md file. So I'm just going for future reference. So I'm just going to have it literally write out what it just gave me to a file because it's going to take me a long time to work through all of this. This is multiple days of work. And I don't want to lose this information if this is indeed the order in which I'm going to want to implement things. So I'm just going to have it write out what it just gave me to a file. And then, in a week, if I come back and it's time to implement phase 10, I could just say, look at plan.md phase 10, and let's get started on planning that phase. That would be so that would be a very simple way to just get started. So do you notice this? It actually asked me if I want to create the file. Isn't that nice of it for a change? Actually asking permission. Okay, so it's again, this is just writing exactly what it told me before. At least hopefully that's what it's doing. Hopefully it hasn't changed things up. But okay, that looks like basically the same plan it had suggested before. I'll say go ahead and write that. And now what you can see, I'm opening this over here. This is outside the container. You can see I've got now it's plan.md. I can cat that. And you could commit this to your repository somewhere or just leave it as a loose file that you could reference it. But the point is, if this is going to be my rough draft of a plan, then I probably want to have it handy and semi-persistent at least. Okay. So then what we're going to do, and I'll now show you kind of the next thing you would do in a riprap workflow. We've planned our architecture file. That's something you do basically once, and then you may have to go back and make some adjustments, but hopefully not many. So you do that once, and then there's a loop that you're going to be executing over and over and over again. This kind of goes back to what Sam was saying earlier. You've got this approach that's waterfall, that's just unidirectional. I plan everything and then I implement everything and then life is good. Well, that's not how it works in the real world. You usually have to have more of an iterative development loop where you're constantly checking to see whether your plan survives reality, which it often won't. So there's no sense in planning every detail out ahead of time. The approach that I would suggest you take is have a really high level plan. That's your architecture.md file. Refine and then you're going when you start working on some aspect of that, like we're about to do, you're going to have a much more detailed plan for that specific aspect of your overall design. Then you'll implement that. You'll review it, try and clean it up as best as you can, and then you're going to move on to the next thing that you want to start planning in detail. So what I'm going to do is say RR plan. This is another skill. For RR plan, uh, what we'll do is uh, I'm going to say I want to plan. Uh, let's start planning phase. And let me just double check. Is it phase one or is it phase zero? How did it number this? Phase one of, and I think I called it plan.md. All right. This is going to execute another plan. Thank you, Levi. So yes, we're over the break time that I had suggested. Let me get started on this next little bit, and then that'll give Claude an opportunity to work away while we're on break, because I think it'll take a little time for this. So I'm just going to go ahead and tell it, let's just start a plan here. And what it should do is something similar to what it did with architecture.md earlier, where it should ask me questions. But this time it'll ask me very specific implementation questions about this specific thing, the things encompassed in phase one of our plan. Um, and so my goal here today is going to be to kind of get through planning phase one and maybe implementing some of it. Uh, maybe even all if time permits. But then I've got some other things I want us to take a look at as far as refactoring codes. But for now, okay, so it's going to take a minute. Um, any questions for before break starts?
There's no additional questions yet, but if people come up with them, and again, in the chat or the Q&A, we'll do our best to answer them. But
Okay.
yeah, also a couple of things I wanted to, I would be very curious to see what people are doing on their own projects here with their own riprap and working with these tokens and these skills. One of the questions that was asked, and because I kind of alluded to this in one of my answers, um, was do we need to ever go in and edit the skill.markdown file? And my answer to that is no, because that's just an instruction for the AI agent itself how to actually run this defined skill. Um,
Okay. So there's actually I've got a whole log conversation about that. So remind me after break to come
yep,
back and answer that, because you're right that you should modify the skill itself, but I do have ways for users to add some customization.
right.
We can get to that afterwards. For now, what I'm just going to do, because I know you all may want to go on break here soon. So what I'm just going to do is I'll get through these questions, and then we'll let Claude can work on writing those requirements over break, and it'll probably take 10 or 15 minutes for it to actually do after I answer these questions. So, phase one covers three fairly independent concerns, and if you recall, it was talking about implementing support for the precision, uh, mixed precision, and double precision, adding the atom data structure, the simulation cells. And it's asking me basically when I write the requirements files, how should I do that in one requirements file or several? Really several. We could talk more about how you make that judgment call later, but three is correct here. Um, what unit system should I use? Okay, this is something that really should have been asked during the architecture process. I think this is something I would want to think about earlier on. And so it's giving me a few different options here. Uh, Real style, do we use angstroms, femtoseconds, kcal per mole? That's fine, but of course you want to think about, okay, can users input in different input or in different units or whatnot? But okay, so yes, let's go with that. And then how are positions stored? So this is one important question that you probably should think about is, do I allow my positions to migrate outside of the primary image? And if I do that, then how do I accommodate that? There's a few implications that it would have if you allowed positions to leave the primary image. What is if they go far from the primary image, then you start to encounter floating point precision issues when you're trying to represent a particle position that's way, way far away from zero if they happen to diffuse a very large amount. So there's some actually nuanced technical considerations that you should make here. What it's suggesting is wrap positions always so that they're in the primary image. And let's see here. What's it suggesting for integer image flags? A per atom integer triplet counts cell crossings so that unwrapped coordinates can be reconstituted. Well, uh, do you need to be able to reconstitute unwrapped cell coordinates? I mean, maybe if you're calculating diffusivity or something like that, it's actually not immediately obvious to me why you'd care deeply about that. Levi, is there you might have more insight on why that would matter than I do.
Yeah, like you might need to be able to calculate diffusivity constants, but I mean that's all things that you can basically work out with the symmetry math later on.
Right,
Like the reasons it's giving for nut two and three are also valid, but usually when we do the wrapped, we typically don't track how many times it's been through, like any one particle has been through
right.
a image. And for those of you who don't work in the classical molecular dynamics space, what Taylor and I are saying in this conversation might be going completely over your head, and that's fine. But this is nuances that somebody working in the MD space and designing these things should be aware of. And the fact that Claude is able, like this AI agent is able to at least call to attention these issues is an important thing as part of learning how to design these kinds of things better. And again, I will reiterate, please, if you're finding things like that on your own, go ahead and post them in chat for others to see.
Right. So yeah, I mean, if you're writing a molecular dynamics code, this is actually one of the most foundational, data management questions that you're going to address is how are the coordinates handled? And if I'm being quite frank, I'm not a big fan of the recommended option one because I'm not sure that there's any deep reason why you need to have those integer image flags. So I would just say, just wrap them. Um, so that's what I'm going to say. But you need to be thinking about this. You need to have a reason for everything you're doing. This is where you as a human matter. This right here, because the LLM will make bad choices, consistently bad choices. I can tell you from working with Heddle, so many bad choices from the LLM that I have had to address. So many bad recommendations from the LLM that I've had to try and guide it away from. Okay, how should the precision features be declared? Um, so this with all of this, you should probably think about it in depth, but I think actually I'm not totally sure what it's asking here. So float 64 is default, F32 opted. That sounds right. Uh, okay, I'm gonna be frank. I don't want to think through that in too much detail right now, but if we were doing this for real, I would say explain to me exactly what you mean by this because I'm not totally sure that I understand the distinction it's trying to draw there. Um, but let's just get it working on something. Uh, okay, so this is the point where Claude is probably going to take a while to write the requirements. Let's take a break. I think we had promised a 30-minute break, so let's do. Claude has finished generating the requirements files. That took about 8 minutes. Um, and so what you can see is it has actually written out three files in RQM. One is called precision.md. That's going to be about the fact we're using, single precision or mixed single precision floating, mixed single precision, double precision, or just pure double precision mode. Uh, Atoms, it's going to be describing our actual data structure for the atoms. Um, and box.md that's going to describe how the simulation cell works. Now, one thing I did take a look at during the break is what did it actually generate for the box specifications? Because I don't actually recall being asked any questions about the way that it's supposed to handle periodicity, other than it's asked a few questions about how it wraps atoms. But it did ask some pretty key questions like, does this need to support orthorhombic cells or triclitic cells as well? Does it need to support situations in which one or more dimensions is not periodic? Those are kind of important questions that didn't actually come up during the architecture planning. But I did notice when I looked at architecture.md, it specifically said triclitic cells are not supported. So that would be one very good example of a place where you want to look at what it has written, because really Claude should have told me I'm planning on writing triclitic cells as out of scope. That should have been a question that it explicitly asked: is how do you want to handle periodic cells? But it didn't. It just wrote that. And then if you look at RQM box.md, which is so these are the requirements files, in this case for how the simulation cell is going to be handled. It says, only orthorhombic geometry is supported. See the open questions in RQM architecture.md. So if I cared about triclitic cells, I messed up pretty badly by not going back and seeing that in architecture.md. Again, this is just emphasizing you really need to look at what is being generated by your LLM. Also, if you just look at this requirements file that's generated, you'll notice every heading has an RQ dash and then a hash. They're all stamped with these hashes, including certain things about the API. The individual bullet points have their own hashes. This is going to be important later on for being able to trace the relationship between the requirements and the implemented code. And by the way, so so there's actually a script that is tied to the plan skill that generates these hashes. Claude is not generating these itself. There's actually a script that does this so that it's randomly generating hashes and then stamping the headers and whatnot. And in fact, I think you should be able to see up here. Uh, so somewhere we should see where it says it stamped them, but I'm not seeing rad2 shell commands. Let's see, can I expand that? Okay, it ran a script rqn.sh stamp, and that's what actually generated those requirements hashes. Sometimes you will find that as your LLM is generating the requirements files, it will decide to just make up placeholders there. So you get a bunch of RQ dash, XXXXXX or something like that, or RQ dash placeholder. That's bad. It's not supposed to do that. The skill tells it not to do that. If you see it doing that, you can tell it. stop and go back and stamp them properly. Um, but what's going to happen is when we write out the code itself, uh, the LLM is going to be instructed by the implement skill to indicate in comments in the code when it is doing something to fulfill a requirement. So we're mapping in an explicit, durable way the relationship between requirements and the code. That's important for a number of reasons, traceability, like Sam talked about, and also the fact that when you're working with an LLM, every time you start a new conversation, it's basically seeing your code for the first time. It's got to figure out which way is up. It's got to understand, uh, what are you trying to do here? What's the architecture? It's got to reread architecture.md. It's got to reread some of the requirements files, but it won't read all of them if you've got a big code. And so this is where it becomes really important with an LLM that when it's going to be modifying some part of your code, that it can check, oh, this code exists for this reason. I shouldn't break this functionality that is called out in the requirements. You'll also notice there's a whole section of uh, Gherkin requirements. So what's going on here is Gherkin is a domain-specific language. It's basically, it's just a way of slightly trying to bridge the gap between informal English and a true test, as in something like a unit test, for example, that you implement in your code. And the way that these are structured is you'll have a scenario here. It's construct a valid cell. And so what we say is that every line begins with an accepted keyword within Gherkin. So when is an accepted keyword. When, and then this feature is going to be implementing a simulation box. So when you create, basically when we say in the code, create a new simulation box of dimensions 10 by 20 by 30, then we expect that that call should return okay. So that's just within Rust. It could return okay, or it could return an error. We expect it should return okay. And we should be able to find when we query the lengths of the simulation box that it is 10 by 20 by 30. We expect lengths to be a vector of length 3. And then if we query the volume, then we expect that it should be 10 times 20 times 30, which would be 6,000. Mid length should give 10, etc. All right. So it's basically just writing out what is essentially a unit test for our code, but it's something like plain English, something almost like plain English. And then we have, what happens if we try to create a simulation box that is 10 by 0 by 30? Well, that's an error. So we should get an error when we make that call. What if one of the cell lengths is negative? That should also be an error. Okay, and so there's just a whole bunch of tests here to consider what should happen under, for all of the different edge cases that you might envision. Uh, and this is going to be very important whenever you're writing a code. You want it to be tested properly. One of the things that it's very easy to neglect if you're just trying to implement something, make it work, you don't care about maintaining it over a long term, is that you're probably going to neglect writing tests. Um, One of the things that the Riprap plan skill does is it says you must write Gherkin scenarios that go through the functionality you've described in your plan, and you need to make sure that you're considering all these various edge cases. What happens if you call a function with invalid inputs, for example? And notice each one of these gets its own requirement hash. So what should happen is when we say implement this, we should get code that includes a bunch of unit tests that are stamped with the corresponding scenario, so we can easily see, well, this gherkin scenario is implemented over here. Now, again, you would want to look through all of this in detail and make sure that it actually corresponds to what you need. I just mentioned that, you know, this made assumptions that we only care about orthorhombic cells. If that's not true, then I need to stop. I need to instruct Claude, rewrite, I would say something like RR plan, rewrite the plan to support triclinic cells. And then it would go through the process again. It would make updates to that box.md file. And we would just want to keep doing that until the requirements files are to our satisfaction. Of course, we don't have a whole ton of time left today, so I'm not going to worry about that right now. I just want to show after we're satisfied with the requirements, what would be the next step? And the next step would be we want to implement something. Now, that would be with the RR implement skill. So we can say RR implement, or if we say implement a feature, hopefully Claude has enough sense to see it's supposed to invoke RR implement in that situation. So you'll notice the little prompt Claude is suggesting is let's implement phase one. Let me just see what happens if I go ahead and try that prompt. What hopefully should happen is it says I am invoking r/rr implement. Let's see what happens. If it doesn't, then I'm going to have to stop this. That matches the RR implement skill, invoking it. Very good. So it automatically saw I'm saying implement something. The RR implement skill is automatically supposed to be invoked when we try to implement features. So it's going to work on that now. It's looking at the different requirements files, and it's going to try and implement these. And this could take a while. As it's doing this, what it's going to do is update me that I'm creating some new source file or I'm editing some source file. And what we really should do is look at each change as it presents them and decide whether we accept or reject the changes that it's making. Um, because I want us to look at some other things while it's doing this, I'm just going to press Shift Tab to say accept edits on. That's not usually what I'd recommend that you do, but I want it to just sort of crunch away on this in the background while we're working on things. Um, any any questions at this point that we should address in the chat?
I haven't seen any additional questions. I'll give people a chance to respond. You did ask me to remind you about editing the skills files, but that if I suspect that
Yes.
might come a bit later, so I just wanted
So,
to.
so actually, I'm just going to start on that right now. So, um, okay, let's actually, well, first let's talk about what a skill actually is. Um, so different different LLM harnesses put their skills in different directories. Uh, in the case of Claude, it puts its skills in .claude/skills, and then every subdirectory is a different skill. So we've got, for example, an RR architecture skill, or we've got an RR plaid skill. Uh, and then within that is something called skill.md. And let's look at the contents of that here. This is what Riprap created when we ran copier. Um, it's got a name. The name is RR plaid. We've got a description. Plan or design a feature without implementing it. Certain skills or certain tools are allowed there. Um, what's supposed to happen is when the user prompts something that matches the description of the skill, then the skill is automatically invoked, and that's what you just saw with implement a moment ago. And what you can see here is that because I'm supporting multiple different LLM harnesses with Riprap, what I do is instead of just copying the same text many different times, I just say this skill is read some central location where I define how the skill works across all the different harnesses and follow it. So there's an open code uh, adapter that it looks almost identical to this, and it just says the same thing. Go read this skill. So this is a little bit different than if the way you would install skills if you're normally just if you're not worried about a general use template. But at any rate, let's follow that advice. Riprap managed skills are our plaid skill.md. Okay, so here's the actual skill that I have written. Uh, so what this one explains is when you're running this plaid skill, don't don't write any source files. First, look at how big the this change is, and that'll determine whether you want to create a new requirements file or just modify an existing one in place. Look at any relevant code, uh, some information about how requirements files are supposed to be to be worded. Um, and if there's anything ambiguous about the plan, then it's supposed to ask the user about it. So it's supposed to help you try to figure out what exactly it is that you're trying to do. And then there's information about Gherkin scenarios, etc. Traceability IDs. So in every requirements files, you've got these requirements hashes. There's a script that is part of the plan that manages that. And so that is going to that 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 is going to stamp the requirements files with the hash so that then when we're writing out the source, it can use those. And if you'll look here, it's writing the source. Here's atoms.rs. It has created, so it's actually referencing right there RQ-E, etc., etc. If you look in the, uh, it's not letting me copy for whatever reason right now. But let me try to remember that. E is 0, 2, 3. Let me get E 0, 2, 3, right? So that's the top. That's the top line hash. But we should also have other things where it's here, can I expand this? Right. So the top of the file is just saying I'm implementing the atoms. But if we go down here further, okay, looks like this is one of the tests it's running. So that's D0C2. Let's see what happens if we look for D0C2. Okay, there's a Gherkin scenario, and it's saying right here, this test through that requirements hash, that test is implementing this scenario. So there's usually going to be a one-to-one mapping between your Gherkin scenarios and your unit tests. Sometimes it can get a little more complicated than that. And then there will be various places in the code where it's referencing that it's implementing some specific API element or that it's implementing some specific feature that we demand out of the atoms representation. We could look for, this requirements hash, and presumably we'd find it's referenced a few times. And so this is all there to make sure that traceability is baked into the cake. You might wonder, so in a lot of harnesses, including Claude Code, there's a planning mode. You can turn on planning mode, and what planning mode usually does is something like it just tells the LLM, don't write anything, just talk to the user about what it is that they want. Um, that's that's not doing as much as this is doing. That's not implementing long-term traceability. Most of that information that you discuss with the AI, it's gone as soon as you terminate the conversation and re-enter into a new conversation. This is going to be committed into your repository and version controlled. It is a continuous formulation of traceability. Uh, you can see that it is at this point asking me if it is allowed to execute a particular command. Now, depending on how skilled you are with Linux, this may or may not seem reasonable. It's doing chmod plus X. Uh, if you've done anything with permissions, then you may recognize that. If not, you may have no idea what it's doing there. And then there's a bunch of other stuff, something about cargo, FMT, etc. I'm just going to say yes, proceed. But what I want to emphasize is uh, LLMs will often, with their agentic LLMs, they'll often ask, well, here's another one. Okay. And this time it's basically giving me a whole bash script it wants to run. Um, and nothing seems particularly exciting there. It wants to run cargo clippy. So it's basically just wanting to lit the code. That's nothing too exciting. But I mean, I've seen it had the, 30 lines of Python script that it's decided it wants to run that make a bunch of system calls. And, you know, when you consider how easy it is to obfuscate code to make something uh, malicious look like something very boring, like a call to a linter or a grep call, uh, there's a lot of danger that you could be going through and just carelessly saying, yeah, sure, you can run that command, you can run that command, and it does something stupid, even if you're trying to pay attention. And so this is again a reason you need to be running in a container that's running rootlessly to try and protect yourself. Um, and you can see it's modifying a file it already wrote, which tells me something went wrong. Um, let's see, did it tell me anything? I mean, it read the linter, so the linter presumably said that's bad. But at any rate, here you go. Here, this is a beautiful example of what I was talking about. What is this? Quick, 10 seconds. What is this doing? Uh, I don't know. We're calling set a bunch, and probably some other things too, and grep. Is this malicious? Is this going to do something bad? I mean, probably not because it's just set and grep, but I don't know. Uh, I mean, I could legitimately code obfuscation is a thing. So I could sit here and say, well, I think I know what that's doing, but do I really? So just just run within a container. Uh, again, I mean, just perfect examples. What is that doing? Uh, okay, so it's just going to keep going away at that. Um, now let's go back, and I'll just sort of switch back and forth between there and here as I try to return to this question of okay, so what exactly? Uh, how would you modify a code, or how would you modify a skill? And actually, it says it right here. So what we have here is it says at the very end of this skill, it is instructing the LLM read dot riprap slash user slash skills are our plan local.md and follow any of those instructions. Those instructions take precedent over anything here. So this is where you can actually modify the behavior of the skill. Because what it will do is it will look inside of dot riprap user skills are our plan local.md. It's just a stub here, but if you want RR plan to do something in particular, or you want to change the behavior, you can write that in here. And that will cause the agent to behave a little bit differently than it did before. So you've got some customization options here. And just as a general rule, let me hop over here just to, yeah, I got to approve a command. And by the way, there, the command was, can I run a script that I wrote? In case you didn't catch that. What does the script it wrote do? I, you should look at this stuff. You should investigate this stuff. I'm not saying be cavalier and just type iter here the way I am, but what I am saying is I don't trust that anyone is actually paying enough attention to know that it's not doing something bad. So your basic line of defense is the container. Uh, okay, so and here it's noticing that it did something wrong, but that's fine. We'll just let it go away at that. Okay, so as a general rule, the way this template is structured is to the extent that it can, Riprap divides skills into or it divides all of its files into one of three subdirectories. So there's the .riprap directory that it creates, and then inside of that there are three subdirectories: managed, state, and user. Managed is template managed stuff. You're not generally supposed to mess with that. Uh, when I update the copier template, I may change some of those files there. If you make your own changes, then when you try to update to the latest version of the template, if you've messed with stuff in managed, it might be a little bit more of an involved process to do the update. You can edit those. It's just try not to. State is stuff that gets automatically generated by Riprap after it's been instantiated into your repository. Usually, again, you don't touch that. The only thing you would do is once project ID is generated, .riprap state, just make sure you commit that project ID to your file, but you don't touch anything there. But that user directory is where we do have stuff that you can edit. You're allowed to change, the skills that are defined in user. You're allowed to. I showed you earlier. Podman has for Podman you can add to the run options uh, that are used to launch the Podman container. You can adjust those there. You're freely expected to modify those files as you see fit. Okay, again, another just lovely. Okay, we'll just let it go with that. Huh. And this could take, by the way, half an hour. We won't necessarily sit here for the whole process. It says final verification, so maybe it's actually pretty close to the end, or maybe it's just final verification for some specific thing. Um, so one other thing that I'll just mention is to update, you just type copier update within your repository. That's it. You just type that. It'll ask you to fill out any of the answers to the questions. What's the project description and what's your email address? But it'll pre-populate that with the answers you already gave it, and it'll update all of the files that the template has updated. Um, if you've modified files that get changed with copy or update, then you'll have to do a git merge in order to resolve those changes. It looks like we've finished this initial implementation. Okay, so this is the point where now um, what Claude is suggesting we do is we just go to phase two. So we could just it's suggesting run RR plan on phase two. That's not what I want to do because here's the reality. We are probably something like 10% of the way through with phase one in reality. Yes, we planned it. Yes, we called RR implement. Yes, as far as Claude Code is concerned, we're finished. But I strongly suspect that if we dig into the code, we will find there's a lot wrong with the code. Um, so let's actually do this. Uh, I'm going to start another container session. So this is in another tab. See, I'm on my host machine in this tab. I'm going to execute rr.sh in another tab. Notice I haven't even gotten out of this container. That's fine. But I'm going to execute rr.sh. This is just going to launch me into another container session. And let's try this. I'm going to run codex. And what I'm going to say is this code includes an initial implementation of phase one C plan.md. I might even say work slash plan.md. Please review this implementation, uh, especially identify any core choices that might uh, lead to problems down the road, something like that. And I might say review it as you would review a PR. And I guarantee you it's going to find some problems here. Even before we as humans lay eyes on the code, it's going to find something. Um, I'm using the implementation requirements workflow because this is a PR review against a phased plan. Look at that. It's reading RR implement. We didn't even have to tell it, but Codex was smart enough here. ChatGPT was smart enough to recognize you're using this skill clearly when you're implementing things. So I'm going to confirm that that the implementation actually follows the code. So it's read what implement says. And notice it read our implement local.md. So if we had made custom changes there, it would have noticed those at that moment. By the way, I don't have to just do this with Codex. Let's try this. I could, while we're doing that, let's run rr.sh. Let me see. Am I able to just copy and paste? It won't let me, so I'll have to type that in again. But whoops, did I stop sharing? Uh, Okay. At any rate, all right. So here in this tab, I've entered the container again. I'm going to say Claude, and I am going to say the same thing that I said before. This repository contains work slash plan dot md. Uh, review, special. Okay, I think that's more or less what I said to Codex. And what I want you to notice is what I have done here is I have started a new conversation with Claude. It has none of the context of the other Claude instance that I have. Uh, so this conversation, Claude is actually, it knows nothing about my code. It hasn't, this is not the instance that this is not the conversation that generated the architecture files or the plan files or implemented the source. So what it's going to have to do is go through and search to try and figure out what have you actually done. I'll start by reading the plan and the architecture docs. It doesn't know what this code is. It doesn't know what the plan is. It doesn't know what phase one is. It has to go through and read to figure that out. And this is why it is so important to have traceability built into your source code. Because if you tell a new instance of Claude, I want you to make edits to a source file. It has no idea what the actual context of that source file is in the overall vision of the code. But by having these requirements hashes and having a plan skill and an implement skill that say if you encounter a requirements hash in the source, go back, read where read the context in the requirements files, then what we're doing is we're helping to onboard Claude. Every conversation you have with Claude is like having a new, it's like having a new developer join your team. It doesn't, there's something called memories with Claude, and there's some ways that it can try and keep a little bit uh of persistence, but basically every time you start a new conversation with Claude, it's seeing your project essentially for the first time. And what this whole requirements-based workflow, the traceability design does is it means you can onboard it very quickly. Um, okay, let's see. Okay, so Codex has reviewed. So let's see what Codex said. All right, review findings. Actually, is there a header to this? No, that's just saying here's, yeah, okay, that's just what it did. So here's the review. Adams validation invariants can immediately be bypassed by public mutation APIs. Uh, so this is, of course, so it's getting into a somewhat nuanced question that's especially hard to understand given that we haven't read any of the source code. Uh, but what it seems to be suggesting is, yeah, okay. So basically it looks like the story here is we've got one function that can adjust set positions and velocities, push atom, but there's other functions presumably that can call that can change our positions and velocities that potentially could introduce NANs. And so we're only checking for NANs, uh, presumably when we create the atom and not later on. And so there might be situations where we need to look and consider whether other parts of the code need to double check whether a position is a real number or not. That's something that, what should we do about that? Well, we probably want to talk with Codex a little bit, uh, and see if it can clarify exactly what's going on there. And then we'd have to think about the implications of different options. Presumably, in a performant MD code, you don't want to constantly check every single number to determine whether it's an NaN or not. Uh, so there's probably a happy medium here. Uh, this is the point where we, as people designing the code, would want to step back and think about this. Uh, Here's another thing. It's saying simulation box values can produce an invalid cell view in the single precision build. Uh, so look, as far as errors are concerned, this sounds like a fairly, if I'm being frank, fairly small thing. But all right, it looks like maybe we want to tighten some validation a little bit. So you can just go through this and try and uh, consider what sorts of issues different models may identify with your code and see if you can do something then to improve each implementation you do before you actually commit it, before you necessarily even do a detailed human review. You can always have your AI do a review and see if it can catch some of the biggest issues. Okay, I told you sometimes it can give you big scripts to run. It's literally giving me a bash command that is, I mean, that's just source code. I don't care how good you think you are with Linux. You have no idea what that just did. Um, okay, so this is interesting. It seems like it thinks that it's honing in on what sounds like a real issue. What we saw with Codex, frankly, the stuff that Codex was picking on sounded uh, like it's worried about whether we're properly validating all possible edge cases And that's good stuff to do. But what I'm really concerned about, especially for this early stage of a project, is has there just been a horrifically bad choice regarding one of the data structures? Uh, is there something where we're not going to be able to fix it very easily if we proceed? Nothing that I just saw there with Codex really implied that. I get the impression that Codex or that Claude here thinks it might have found an issue that might be a little bit more significant. While it's doing that, let me just show you something. Here's HeddleMD. So here's a much more mature code. This was developed kind of doing the same sort of thing. Um, but what I did was I asked, I think it was Codex, to go through the code in detail and see if it could identify any problems with the code. And I did this just a day or two ago. And here's the review, and it said, here's some problems that I found in the code. And it has some nice things to say about the code, which I like. And then it says, okay, here's some problems that we found. Uh, and it's calling this a high priority problem. Uh, and by the way, as you can see, I wrote the output that Claude gave me to a review.md file so that I could then, after the fact, have Claude consider these and then maybe fix them. So here it's saying, its number one problem, constraints silently accept non-convergence. So there's this issue where shake and rattle, they have a fixed max iteration, and they don't return any specific error if they don't converge there. So, okay, that sounds like something that probably should be addressed. It's not a massive, structural problem. That's a sounds like a pretty easy fix after the fact, but that does sound like a real issue. It says top level config typos are silently dropped. So here it's talking about if somebody, it's saying if somebody writing an input file types something, has a typo in something, um, the code doesn't, in one particular place, if there's a typo, then there's no error message. The code would just run, but without presumably whatever the user intended. So that's a real issue. That's not like the underlying physics is wrong, but that sounds like something that yes, we would actually want to fix. Uh, and some of these are, a little bit maybe smaller issues. This one, RDF misnormalizes on variable cell trajectories. Okay, that actually sounds like a big issue to me. It's basically saying when I have the code do uh, evaluate RDFs, radial distribution functions, it doesn't properly account for how the cell size changes over the course of an NPT simulation. So, okay, that's actually a thing that should get fixed. And so, you know, these are not these mostly sound like real issues. Uh, some of them aren't what I would consider massive issues, but they should be addressed. So what I would do here, well, first, what I'm going to do is go accept whatever ridiculous bash command Claude wants me to over here. But what I would do is, so I would launch a container session, uh, and sometimes what will happen is you generate a review like I just showed you, and it's kind of nitpicky, or a lot of the suggestions are just bad, or it'll just be outright wrong. I mean, I've had plenty of times when Claude or Codex suggest something that is just wrong. They say they find a bug, but it's not actually a bug. So what I would do here first is I'm going to tell Claude, please examine point one of review.md. Let me just open up a terminal so we see that again. Okay, so and that's the constraints silently accept. Oh, well, it's not letting me. Let's just say the constraints non-convergence issue. Please verify whether this is a real issue. Uh, so what I would often want to do is just have an agent in a separate context actually look and see, is this just a hallucination? Because oftentimes you will get a hallucination. And oftentimes the agent will be able to an agent will be able to quickly tell me, no, this was not actually a problem. The agent that wrote the review was just confused. Uh, so while we're having it do that, okay, let's go back here. Sorry, Claude has written its review of the code that we did before. This is a much more detailed review than what we got a minute ago from Codex. Uh, It says, okay, this is unusually disciplined phase one work. Requirements IDs, trace. Oh, look at that. Riprap. It helps. That's what that's saying. Riprap helps. Um, but it says there's a few issues. The Adams accessors cannot express a force kernel. Uh, so it says it tried to write basically a temporary, just a test loop to evaluate forces, it looks like. And and it claims that something went wrong. Uh, okay, so I would have to sit down here and really spend probably 5 to 10 minutes understanding exactly what's going on here. But I think that just by spending about 10 seconds glancing over that, I think what it's complaining about is that Rust has very strict requirements on um, with something called a borrow checker, and yeah, okay, that's it. It looks like we are running afoul of the borrow checker when we actually try to take the positions stored in the way that the positions are stored and put those in something that would be a force evaluation function, like you might write a force evaluation function. It doesn't actually work. So we would need to go back and reconsider something uh, about how those positions are handed out. Um, so that sounds like a real issue and a serious one that requires going through in detail. There's a bunch of other things here. I would probably just say, please, write this analysis to review.md for future reference. And then this is something you could just keep going through. You could have Codex read the review that Claude just wrote. Ask Codex, can you verify that what Claude claimed here is really true, or are you able to write a force function that that works with the current data structure? Uh, okay, let's go back here. Sorry for all the context switching, but that's kind of a thing that you tend to do with LLMs is while one's working on something, you maybe have you maybe start talking with another one. And it's saying, yes, this is a real issue. This was the issue with the constraints can potentially, hit maximum iterations and uh, not actually express any error or anything like that. Uh, so so it's saying, yes, we should probably address this. Notice, okay, this is where requirements traceability is so important. This was a new context with Claude. It has not it before we started this conversation, it had not seen any of the source code, it had not seen any of the requirements, but it was very quickly able to say, I looked at the requirements documentation for how Shake is supposed to work, and um, what what the requirements claim is not actually uh, is not actually what was implemented. Uh, let's see here. The last clause is false. If the loop exits at max iteration, uh, the residual is by definition above. Okay, yeah. So the requirement basically has two statements here, and uh, one of them is there's a claim that your per step residual is bounded, and the problem is that's not actually compatible with the first half of the requirement. So there's something about the requirements here that's actually quite stupid. Okay, so this is something that I should have caught in looking at the requirements that this sentence cannot be true. Um, so that's a good reason to look over your requirements carefully. But this is a place where, thankfully, with some review and concerted effort, we found that there's an issue here. And then we could go through and we could start a so it's proposing a fix. And by the way, I am not actually committing this to Heddle as is. This is just a separate brand. I'll work on actually implementing this properly uh, later. But the basic strategy would be okay. So please write a plan um, that reflects this proposed fix. All right, so then we plan it, then we'd implement it after it's finished planning. Um, okay, so that gets us towards we're getting towards the end here. Uh, any questions?
So thus far, there haven't been specific. Like, there's one specific question that's come through the Q&A, and I think I've answered a lot of these. But some of the other people are asking some very good open-ended questions, and I kind of want to share them with um, everybody else here if you haven't been able to follow the chat. So one of the questions asked was, since we're using an LLM to generate this code in a container, should we expect our users to run the code, the output code in the container as well?
Yeah,
So do you want me to
that's a very good question. And the answer is right now, Riprap doesn't do anything to handle container deployment. It's really just we're trying to help you develop within a container. But I do recommend deploying codes within a container. And so I think it would be great if you created deployment containers, not only because that's just a good way to distribute, but also because if you think about security, if you have an LLM that maliciously creates something bad, if it injects something malicious into your code base, one way to mitigate the damage that that code can do is you only execute it within a container. Because if you've got an LLM that is bound within a container, but it generates code that is executed outside of that container, it's actually not that hard for it to do some damage.
And as an extension to that, I would also argue that there comes a point where your users have to trust you that your code does not intentionally do harmful things. And that's something you as the developer kind of have to check over. Now, there's no assurance of that, especially in the open source world. That's why, and especially with things where dependencies and upstreams can get attacked. But that's why a lot of licenses will say this code is provided as sort of the company's way or the developer's way to sort of cover their bases and say you can't like we're not providing this maliciously to the best of our knowledge. Um, but yeah, and then you went off and Taylor, you showed that yeah, you can have another AI agent critique the code that you have provided and look for those things. Now, I will caution, just from a personal experience, how you phrase an AI agent to look for malicious code in your code is very delicate because if the AI agent thinks you're trying to figure out how to hack a code, it might think you are trying to be malicious and stop talking to you. This was a big problem with Fable. I have accidentally done this with my own Claude account where because of my lexicon and how I was describing, hey, can you help me hack together these two functions into something where I was like trying to remove what ultimately was a triple loop in the code. And it was like, I think you're up to no good. I'm going to put some tighter restrictions on your entire Claude account, and you can't prompt me for certain things for like 3 days.
And actually, I think something similar to that, I don't recall quite the details, but something similar to that happened with the Hugging Face attack, where I believe Hugging Face tried to use ChatGPT to help them figure out why they were being attacked. And it told them, no, we think you're hackers, as ChatGPT was trying to hack into their systems. So they ended up having to use an open source model that they were running locally in order to resolve the issue.
All right, another good question that came through, and I'd like to get Taylor and Sam's opinions on this one in particular, is
Yeah.
what for question and answer, do you think that there are certain types of development that Riprap will better lend itself to? And sort of more broadly, in our experience, what does AI struggle with more or otherwise? And what level of care are you advising for this agentic coding? And is it a really time saver compared to primarily your writing code yourself? Now, my answer to that question is that the more open source examples that exist of that particular domain, the better the agent is going to be. And on the your side of that is that the better you are at understanding that domain's implementations and theories, the easier time you're going to have getting an agent to do the more complex things because you'll be able to correctly structure the way you are instructing your agent to work on developing those things. That and if this is something completely out of your wheelhouse or something, like a domain inside of Wheelhouse, you can probably eventually get an agent to where you think you want it to be, but it'll be slow and inefficient getting there, or a bit of a grind, and it'll be hard for you to verify the validity of its work. But Sam, Taylor, I'd like to hear your opinions on this particular question.
So my experience, at least with Heddle, has been that the thing the LLMs struggled the most with by far was performance optimization. And this probably gets back to what Levi was saying. It depends on having lots of examples that exist. And there's not a whole lot of high performance code out there. In fact, even people who probably should be developing code that performs well, I'm kind of shocked sometimes when I talk to people who are just general computer scientists to kind of find out that computational chemists, I think, know more about performance optimization by far than the average computer scientist. There's a lot of things we know less about, but performance optimization is something we care about, and whoever is developing, your browser and your operating system and your text editors apparently doesn't know about or care about. And so I think LLMs struggle mightily to try and reason through performance optimization. Also, just because it's very, very subtle. There's so many things that could be a bottleneck. I've had LLMs claim that they found a problem, uh, when in fact they're just misinterpreting the data.
As a computer scientist, I will respond to Taylor and say that this is because as computing power has increased, many of the tasks most general computer scientists tend to focus on, things like your text editor, don't need to be as performant to still satisfy all customer needs. So there are different kind of edge cases in the computer science field where they will care about those, but a lot of them, yeah, it's kind of like, hey, it gets the job done fast enough. I don't need to worry about it. Um, and I'll just kind of echo what Taylor and Levi have both said. We're even going beyond necessarily like specific coding domains. It has been my experience that in terms of overall software, the AIs are really good at anything that is kind of more like a common problem. So you're trying to get it to help you write a container file. It's going to be excellent at that because there's tons of examples. They're very formulaic. Boilerplate code, a lot of code that's like kind of commonplace So web development, it's very good at web development because there's tons of examples online everywhere that they can scrape from. If you're trying to push the boundaries at like the very end of like research code development, that's where, in my experience, it starts to struggle because there's not as big of a weight for it to like build upon and then utilize to recommend new things to you. And so, as Taylor said, like on the performance side, it's not going to be as good at that because both there's not as much examples, and two, the performance of your specific code is going to be, I'm not going to say unique, but it's going to have more unique aspects to it than just say, help me build a web page. And so uh, the differences in what your code is trying to do from the norm, like the further you get from common tasks, the harder it's going to be to get it to give you really good results.
And being able to contextualize tasks in smaller bite-sized chunks and give them the requirements that sort of that Riprap is doing for you, that helps the agents better dissect things because as we saw yesterday, when you say write me in MD code, it kind of comes up with something. But then here today, we spent, 3 hours delving through, okay, let's do maybe 2% of the actual code that might wind up going into an MD engine. And it took a lot of iteration and it took a lot of understanding of what's the theories behind these just from the developer. So in a lot of ways, we're the developers aren't going to be replaced by these agents because we constantly must actually understand what the agents are trying to spit back out for us and be able to use. So those are a couple of very good questions. Also, if anybody else has other questions, feel free to put them in the chat, put them in the Q&A. We are in the formal Q&A, sort of, I guess, the dedicated Q&A session right now. There
Yeah.
was a question that did go to the Q&A, Taylor, and you might be able to answer this more specifically, is that does Riprap have specific what's the specific nature of what Riprap has for testing and bug finding and workflow management? And I think you went through that, but there's also a level of by us requiring, actually having fixed requirements that then the agents are told that you must adhere to that. The way the agents were built, like by their programmers and stuff, is they're going to try to solve those requirements because it's a coding thing through testing, through design, and through acting like a developer because that's what it thinks we want. And so by manipulating that,
Yeah.
we get out the good testing and something we can build off of.
Yeah. So, I mean, as far as review, at some point, I probably add something like an RR review skill or something to that effect. There's just nothing quite like that at the moment. Um, there actually is for the requirements traceability, there is some sort of linting uh, available through that script that I mentioned earlier that the AI is invited to run. That does some linting to confirm whether there's any uh, orphaned requirements, hashes, and whatnot. So there's a little bit of formal review to confirm that the requirements are at least look like they're traceable. Um, but yeah, I think some of what I just showed you as far as just literally prompting the LLM, please review these changes. That's what I've mostly been doing lately. And obviously it is true that exactly what you're going to get depends on what exactly you say there. And if you say, find me some problems with this code, it's going to give you a list of problems, some of which may be hallucinated. So, as it currently stands, if you go through that process that I just showed you, have an LLM review your changes, um, you could go through, you want to make sure that you're confirming that the things it claims are a problem are in fact a problem. Uh, that it's not just hallucinating an issue, that it's not just suggesting that you move code around to uh, no real effect, that you're not making things worse. And probably at some point I want to have a skill that tries to encompass some of that, but I don't quite know how to express that in a general way to an LLM yet. Right now, I would say it's mostly just there has to be a fair bit of human review going into the process and a fair bit of human involvement. People like to talk about human in the loop, and I always find that an obnoxious phrase just because it kind of invokes the idea that you give the LLM a problem, you walk away, and then every once in a while it asks you permission, and you just try and make sure it's not launching any nuclear missiles or anything. I think that's a really bad way to work with LLMs. And so, what I would suggest is a very involved process where you're constantly checking to see, has the LLM lied to me? Has it done something stupid? Um, is it hallucinating right now? I don't think you can automate that. I don't think you can just have, the human be, 5% of the problem. That the human really should be driving the loop. If there's a loop, the loop should be entirely driven by the human saying, all right, I've satisfied with the plan now, and I am going to move on to the implementation step now. I am satisfied with and now I am conducting my review, and now I am going to say it is time to move on to the next planning phase. Um, it should be that as opposed to, every once in a while the LLM is going to tell me it's finished implementing and reviewing things and it's happy with its own work, and I guess I'll just check the box. That's 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 the way a lot of current LLM workflows start to look. And I think that's where you get just unmitigated slop being produced. Um, I'll just since we're close to the end here, I do just want to show a couple slides. So I had showed you this yesterday, because this is actually a pretty good example of what we're just talking about there. So I I was working on HeddleMD with Claude Code. I told it, and you just need to have a little basic background that there are a couple of relevant requirements here. Oh, did it say screen sharing paused? Can you see my screen there?
Yeah, we can.
Uh, okay. Uh, so one requirement says every particle in an input file has to be within the primary image, which is just there to kind of make sure the user hasn't done anything silly, hasn't made a mistake. Um, then there's another requirement, let's call it requirement B, that says when you're outputting a trajectory, the format of your output should match the file format that is read when you read an input file. It should be the same input uh, format, and it explicitly says so it should be possible to take a trajectory frame, basically just copy and paste it, and reuse it as an input file. Which, of course, what this implies is the key thing that this implies, obviously, is that when you output your trajectory, all of the atoms that you output should be wrapped into the box. They should all be in your primary image. Nothing should be outside of that primary image. That's what that implies when you put A and B together. Uh, so I tell Claude Code, all right, I want you to go ahead, run a calculation, take the output from that calculation, the output of that trajectory, the last frame that it prints, and just copy that into an input file, start a new calculation. And what it does is it runs uh, heddle-lit to check if this input file will actually parse. And it says, no, it won't. And the reason is because we've got a particle that within this box that spans negative 0.5 to 0.5, it is at fractional coordinate negative 0.5001. So that's obviously outside the box. Obviously, that won't parse. That violates requirement A. Um, and then it goes on to say the extracted frame has an atom at fractional coordinate negative 0.50011, just outside the box. That's a real round trip gap. The trajectory writer emits coordinates the initialization parser rejects, even though frames are documented as valid input files. So in other words, it's recognizing that there's a conflict here between requirements A and B. Requirement B says it should be a valid input file. And then it goes on to say, because it looks a little more deeply, and it finds there's actually 6 atoms in total that are overshooting by up to 0.012 angstroms. And then it says this is a F32, a single precision float rounding right at the box face. Benign, but it does break the documented frames are valid init files round trip. Okay. So I had raised the question yesterday. If you're working with an LLM, trying to make sure that everything is working properly with the way your input files and your output trajectories are handled here, what is your next prompt? What do you say at this point? So, what option would be, maybe we say, would we are getting ready to output the trajectory, we need to just wrap the atoms again. Or you might say, well, maybe we're being too stringent with the requirements files. Uh, let What I did actually here is you can branch a conversation. And so I branched this conversation and I said, as soon as I saw this, I said, I want to try 2 different things just to see where we go. So here's one branch of the conversation. The next thing that I say in this branch of the conversation is, earlier in the session, you attempted to add an output frame into a new input file, and then I just sort of summarize what it said. And then all I do is I just hand off all decision making to the LLM by saying, what would be the best course of action for resolving this issue? Here's what Claude said. The right fix is in the writer, not the parser or the extraction script. Reasoning. Why the writer is the culprit. The engine's runtime wrap already targets the range of minus 0.5 to 0.5. The 6 offenders are floating 32 round stragglers at the exclusive face. The writer just faithfully mirrors that state. So the invariant is broken. Uh, Recommended fix in the trajectory writer before emitting each atom, before writing it into its trajectory file. Wrap it into that range. Uh, it's 6 slides. It's local, costs nothing, measurable, preserves what the docs promise. Okay, so that's what Claude suggested there. That's not what I did, though. Does anyone see a giant red flag here? Does anyone see a reason to not trust Claude here? So here's what I said. This is a different branch of the conversation. Again, I just said earlier in the session, you found this error. So that first paragraph, that's exactly the same as before. And then instead of saying what would be the best course of action, I said, I'm somewhat surprised that the fractional coordinate rounding error would be so large. An error in the 4th significant figure sounds large even for F32. Do you see the problem here? If you're familiar with floating point precision, that should be accurate. If we're just talking about an F32 rounding error, that should be on the order of maybe 10 to the minus 6. This is an error on the order of 10 to the minus 4 or even 10 to the minus 2. This is way big for F32 rounding error. Claude, good catch. I had waved past that. An F32 machine epsilon and coordinate of 2.5 nanometers is around 10 to the minus 6 angstroms. And the observed overshoot was 4,000 times larger. Floating 0.32 rounding at the box face doesn't explain it. Let me actually investigate. Oh, well, that would be lovely. And then it goes on to say, you're right, and my diagnosis was wrong. This isn't float 32 rounding error at all. Here's the actual mechanism. The engine's convention is that positions live in the primary image. That's why we have separate counters. Settle, so one of the constraints, breaks that convention, it reconstructs the molecule contiguously to compute the correction and then writes back into the contiguous frame instead of the primary. So in other words, what is happening is I have a constraint, and the constraint only makes sense with, when it's dealing with atoms that are nearest that are following a minimum image convention between one another. And it says this one kernel is shifting those atoms. It's wrapping them into a minimum image convention, and then it doesn't wrap them back. And so the whole architecture of this thing is supposed to follow the pattern that everything stays in the primary image all the time, or at the very least, if you're subtle, you should be wrapping back. But I've got a constraint algorithm that is violating that in a way that actually has direct downstream effects. So if I had gone with what Claude wanted me to do, then I would have just papered over a real issue that's probably going to cause more problems later on. Now, what really should have happened here is I should have caught, when initially implementing settle, I should have caught that it was doing something wrong with um, with shifting which image some of the atoms were in. So I failed there at some point. There was probably some giant red flag I should have caught. But here, Claude does something, and I actually do notice it and do resolve it. But this is the sort of thing you have to deal with constantly with these LLMs, is you have to constantly not trust them because they will just make things up. They will give you explanations that are not justified by reality. And then if you actually understand something about the physics, if you actually understand something about the computer science behind what they are claiming, you say, wait a minute, no, that doesn't actually work. That explanation doesn't make sense. Verify whatever your LLM is claiming. Um, okay, so that's I think a nice little example of why you just can't trust an LLM. And why when you're reviewing what an LLM is spitting out, you just have to constantly be on top of it and constantly be thinking, does that make sense? Do I understand this? Do I understand this? If you don't understand it, it could be that it's an opportunity for you to learn something, and it could be that the LLM is just making up some nonsense. But if you don't understand it, stop the LLM, say, explain this to me. I just don't get it. What's the rationale? Try and verify it independently. Okay, that's pretty much our time. Any other questions? Anything else?
We haven't had other questions come up in the chat necessarily. A couple of suggestions for things we might be able to do to improve Riprap for other skills that we can build in. But other than that, I think that's it for what we have for the workshop. We really hope that you've all found this particularly helpful and beneficial, and we hope that you've learned a lot on how to actually work with these AI agents and use tools to become better developers and programmers yourself, especially as these AI agents are very, very, very rapidly changing themselves and changing the landscape by which we do programming.